Morning, everybody. Welcome back. Day 3, the hump day. And I want to remind everybody the context. Remember, this is a governance, risk, and compliance, and we need to look at the big picture here, the captain's view. And we know that what we're doing is representing the ISO. You're here to get a CISSP or all the classes we teach are ISO 17024 accredited certs. And currently 172 member bodies from Afghanistan and Zimbabwe. That's what we're here. We have very challenging times right now. And the worst risk of AI is bias. It's actually control and bias. If you don't know the risk, we'll talk more about it on Friday. But the AI risks basically come down to just like the car, I can't control it. It's like imagine that the wheel's constantly moving. You turn left and it goes right sometimes. How are you supposed to fix that? You can't drive a car like that. When I was a kid, we used to build go-karts, and you need to steer. That's the basic governance. So I have a steering wheel, which was just a rope tied to a 2x4 or whatever board we had, and two wheels from a baby carriage we pulled out of the trash. And we were like, I hope that steers. We're going down a hill, and the red light compliance comes in. Maybe we could steer. There was a good chance we were jumping off it and letting it hit something. I didn't, wasn't exactly safe for the common good, but I was 11 and that's what we did in North Philadelphia. It's hard, but that steering wheel was never going to learn to control itself. I'm very hopeful that AI is going to learn to control itself much better than any human could control it. Every human that wants to control it seems to have a biased interest. Our country versus their country, but we don't. The CISSP knows it's everybody. There's a golden age. We're about to solve a lot of. I don't know what problems you have that you don't think some intelligence 2 times, 4 times, 64,000 times smarter than you might not be able to suggest some better options. I'm very worried about the environment. I'm more like, hey, if we get this right, it's probably going to come up with options to save the environment we never thought of. So here's our job. This is what we do. As we go through our mission, and a great way to select why A is better than D is to remember the big picture. What is the scope of this particular mission? And you got to look at it from someone's different perspective. I didn't expect that to be so thick. Why is my pen so thick? I don't feel like solving that problem right now. So it depends on the perspective of who we work for. In a computer, we generally work for people who are trying to do stuff, and that's when Arpita, you bring so much of a better view. The people they're trying to, like, if I was a customer that wanted to go to a restaurant, the people who work at the restaurant, the server. So now you get the client and the server, and what Larry always did, the network. And it's not the network's fault. No, I'm sorry. But that's what you basically want to do. You want to look at the governance from the client's perspective, ultimately. That's the human thing. The services they're trying to get to, the food they're trying to get to, and the transport mechanisms in the middle that provide that. And if we can secure, in a timely fashion, because I always look at what is the latency on the network, the client, the server, and all the transports, then we're good. Those are the scopes that we look for. And we want to do that. And there might be 2 answers that do that. Which answer did it in less time or less cost? And that's probably the better answer. So always keep this in perspective. Now, again, 2 answers might do it. But if one costs less money, we are more precise. They were both effective, CMMI level 1, ad hoc, whatever. This was the most efficient. You didn't throw anything at it. You were able to use the entire animal. My bass player, my one band, is one of those guys. He gets real mad, and he was right. It turned out he was buried out that fat's not really that bad for you. And he would go into, in the old days, but it was because of the Crisco company that tried to convince us. And that's his whole conspiracy about the Crisco oil company. But whatever, I'll let Doug go over this conspiracy theories there. All right, now the other thing we always want to make sure when we're taking the test is especially in any scenario, wait a minute, where are I? Where am I in time? Where in the sequence of time? As a network guy, what TCP state? Is this a SYN, a SYN, a HAC, a FIN? Where am I? But here, where am I in this life cycle? And a lot of questions, again, we'll ask you, for instance, you may be here, and they got three answers. One's here, one's here, one's here. They're all then. Which is the next step? Well, I mean, eventually they're all the next step, but this is technically the next step. Sometimes this won't be here, and you're like, that's not right. Wait a minute. First of all, they left out an element. They don't even have that there. Then answer this one. Go to that one. Don't sit there and argue with the test while you're sitting there and getting angry. That's just going to get your blood worked up. And when the next question comes up, it's really easy. You're going to still be mad. And I don't know. You're like, yes, you do. CIA, confidentiality, integrity, and availability. You knew that. Yes. So just take it with a good sense of humor. Be a good sport. Don't look for the right answer. Look for the best of the four. Sometimes it's the least wrong. They're all wrong. Not usually, though. I actually, again, I'm very happy with the latest test. I really, really am. I did not find it was written in their language. I didn't find it was written in bad language. I didn't think it was biased toward anything. I didn't think it was old. I was very happy, and that's why I'm still doing this. You think an old man, 63, would be doing something he didn't like? Hey, I wouldn't be selling you stuff I don't.
You're only happy because you passed without studying.
I study like crazy, and I learned so much from Arpita joining. I don't know that I would have passed it easily. I would have passed it easily. No, I'm always studying, always studying. My teacher, my martial arts coach, Tom, says all the time, always the student, sometimes the teacher. And I hope I live up to that. Always the student. Marcus, I thought I saw you sign in there, and Kim, I don't know you ever met. I don't think we've met in person, but Tom is 77, and he just kicked my butt, and I'll show you guys. It's so awesome. But I learned something. Again, I learned something. I'll show you what I learned. All right, so we did this. We initiated on day one. We analyzed yesterday completely the asset requirements. We classified our data. We made sure that when we figured out exactly what, it's not on a line by line item. We said, no, anything whatever high confidentiality or anything top criticality will be treated this way, right? High integrity stuff will always have to be digitally signed. And so when you get new data, the data owner sets that classification scheme, and then any data steward or whatever will then enforce that. Of course, in like a PII, the European Union set that what you're going to do, and you don't have any data owners other than the subject themselves, but any controller is a steward of those GDPR requirements, right? And they know how to classify that and how to treat it. And then we as architects design that. We're like the waiter that understood what they wanted and design one of the answers on that menu, G or A, B, C, or D, on, yeah, I think this is how to get them what they just said. All right, that's our goal. Our developers start building it. And again, the problem is many of us, me, have been so many years being this person. And when a cook, a chef, tries to be a waiter, I have a feeling that risk of misunderstood orders goes up. Remember, I said if you get the wrong food at a restaurant, it's probably not that they cooked it wrong. It's probably that they got your order wrong. That risk goes up when a subject matter expert tries to work with customers. We all know that brilliant person that you can't put in front of customers. Don't be that person on the exam. And then you test it. Now, this person can test the little part that they developed. In today's microservice world, the way we collaborate in cloud-based DevSecOps stuff, you're probably just developing, all right, like if this was a Subway restaurant, you just work on the cheese, whatever, this microkernel or whatever, and then you could test that part. But then the user of the application that takes all of the software bill of materials, it has to use the entire application and go, yeah, user acceptance test. We deploy it. We get to use it. But nobody loves doing this. It's just not fun to have to do the dishes. I love cooking. I don't love doing the dishes, but I am picky. I don't trust anyone else to do the dishes. I don't even trust dishwashers that much. I grew up washing dishes, and I think I do a better job. Hey, you take that automobile. I'll take old Betsy. Maybe I'm sure if I had a better dishwasher. All right, so this is our context. This is where we stay. We stay in and as we're designing, we were designing stuff yesterday. We started. What's kind of funny is where they throw design physical now. It's not in architecture, and hopefully we'll get through it. It's actually in access control, and it makes sense, and that's why they simplified it. So the physical security is now completely moved in access control. So we should be able to finish this up. Let me go back to my design where we are. And I think we were right about here. Does that make sense? We were talking about cryptographic solutions. I moved around. Please correct me.
We were doing the software as a service, infrastructure as a service. I think we stopped at that. We didn't do that yet.
I thought we did this.
Yeah.
So did we get through this already?
We could do a recap. I'm not
Yeah. You know, you get older. I remember stuff I did when I was 4 years old. You know, detailed. I don't remember what I did yesterday. Crazy. I don't even remember why I got to the refrigerator. So we know that again, our cryptographic solutions. I was playing again with my Wireshark. I don't want to get too detailed, but I want to keep it in focus again. Why? And let's look at what the server chose, but it could be any one of these. So this is what the client says. The client, when you handshake with a TLS server, and there's always some handshake to negotiate something in any communication protocol, right? Are you using 8 bits, you know, whatever. So the handshake and the client offers, these are the algorithms that we support. And we know that the algorithms we use to encrypt data, oh, why is this pen so thick? What the heck happened yesterday? Is there a configuration tool? Now's not the time. Then, oh, there we go. Hey, all right, we got that. A little thicker. There we got it. Sorry, guys. All right, so, and it should be blue, Larry. I thought symmetric was blue. It is. AES is pretty much the only street legal, possibly we're going to see this because it's going to be faster. That's its only proof. And anybody know why I know this is going to be faster, even though I've never seen it run? I've never seen any server select this. That's because the Old Testament AES is a block cipher. It reads in it just like reading a deck of cards, you know, and shuffling the deck of cards. You know, I read in 128 bits at a time and I shuffle the deck. You know, it's a block cipher. Where this other street legal, I've never seen anyone select it yet, but Cha-Cha Pa 20, whoops, this is a stream cipher. And we know that the difference is that stream ciphers, if you wanted to encrypt a word, I could very easily just say, hey, from now on, the letter A, I'm going to substitute with the number 1. B is going to be number 2. And so now people who are reading it, they're like, I don't know what this says, just numbers. I substituted something with something else. Stream ciphers are substitution ciphers. That's what they do. It's a lot more complex than that, but they use substitution. Well, doesn't a block cipher do that? Sure they do. Yeah, they also substitute. But do you know what else they do? They shuffle the deck of cards. They're also transposition.
Hey, Larry.
Yeah.
When you're talking about crypto, there's a couple of times you use the term street legal, and I can take that a couple of different ways. What do you mean when you say street legal?
Oh, just like you can't have like, you know, when I was a kid, we rode mini bikes, you know, or even my go-kart. That was not street legal. We were really not supposed to be on Broad Street in North Philadelphia. Well, we didn't, it was crossing Broad. We tried to stop before we hit Broad, but either way, it's not street legal. We used to drive mini bikes. We would ride them on the sidewalk. You know, it's not, if a cop pulled you over, it's not legal, right? You get a ticket. If you want to be FIPS compliant, or some other compliant property. If you were going to go to court, somebody said, why'd you choose that cipher? You better pick AES. Because otherwise, I've never seen anybody in a modern encryption handshake. And, was it Paul from our crypto place? I don't mean to call you out if you're there. Do you know any place that does anything but AES? Maybe on someone's local hard drive, which doesn't have to go on the hard. And that's exactly what I do. When I encrypt, and I want to drive my mini bike on my property, I actually choose Bruce Schneier's Two Fish because I just like the guy. So, and it was supposed to be AES, and I don't want to go down that rabbit hole. So I do when I don't have to drive it on the street, but when I know I'm connecting to something in the Federation, anytime you connect to anybody on the internet, I'm willing to bet it's AES. It's the only one that's certified. Does that make sense?
Yes.
Now, they make sure that the data isn't tampered with, we know, with a hashing algorithm. And the only street legal ones today are SHA. There are various flavors of SHA. We should not really be seeing this. I think this should have gone away. And if servers are selecting this, I have a feeling we have some policy exception report for whatever reason, probably in the government. I don't mean to jump to conclusions here, but this is where my imagination goes. No, they still can't at the Department of Agriculture. And I don't mean to call it that. I just made that up. But they still got to maintain those things because they can't do the sewers yet. And so this is here for some reason, but I don't believe it should be. Google showed a collision attack. That means I can take the same whatever Service Pack 2 for Microsoft and get it to come out to the same SHA, the plain one's 160-bit hash. That's a collision. That's a bad thing. That means the virus infected one looks good. And Google was able to do it with their computers in 2017. By 2021, I heard that it's a lot easier with today's technologies. So I'll just leave it that way. So it really needs to go away. We should be at a bare minimum here. This is the same entropy as AES 128. You always double if you want to get that techie. Don't worry about it for the test. But if you want to get that techie, and no. Just as with Moore's Law, this is not likely to go before 2065, according to my AI assistants, by brute force. And this is the same. If that's not good enough for you, if you think, nah, I'm worried, what about 2066 and I get sued? You can do this. To me, it sounds like you're driving 35 miles an hour when the speed limit's 60, but, whatever. Stay in your lane. Now, to ensure that only Bob, remember your asymmetric keys are your identity keys, they're green. Only Bob could have either the key or sent the hash. We have our asymmetric keys. Elliptical curve Diffie-Hellman or RSA are our only key agreement protocols that we support today. What is an elliptical curve Diffie-Hellman? Well, Diffie-Hellman created the very first key agreement protocol. Up until this is the first asymmetric federation certified. That means here's another one for you, Kim. A lot of times when I say certified, it's either the ISO or in this case, the Internet Engineering Task Force, the IETF. They make all the RFCs, why TCP is formatted and IP is formatted the way it is. And they had accepted an asymmetric key agreement algorithm of Diffie-Hellman. And so up until then, if I wanted to get you the symmetric key, you wrote it down on a yellow sticky and sent guy over there. Hey, it's over here. If you wanted somebody from San Diego to get a key to a guy in Guam, you sent a guy, a courier. Now, in radio communication, they would do it in a separate set of channels. Don't go on 93.3 to send the data that's going to be encrypted. You got to get the key to them. So send it a different radio band, out of band key exchange, but whatever, yellow sticky. Now that we have Diffie-Hellman, these two partners can agree on a key. I don't want to go too deep here, but it's kind of cool. It's kind of cool. And I want you to think about what could go wrong in this scenario. Bob and Alice are at Starbucks, very crowded, tons of people there, and Eve is one of them, the evil eavesdropper. And she wants to know what they're going to do. And they're going to come up with a 128-bit AES key. And they're going to do it without ever sharing a yellow sticky. And Bob's going to do it. And in real life, these must be prime numbers. That would make my drawing very ugly and complex. So let's forget the primes. But Bob would think of two, a private and a public number. Privately, he thinks 9. Publicly, he yells out in red text. That means clear. Whatever. 7. And Alice does the same thing. She yells out her public number. 5. And she keeps her private number. And that's whatever, 3. And now they are going to do a little formula where they raise it to Bob's, which he didn't yell out, 9, and to her value 3, which she didn't yell out. So Bob has to figure out what Y is, and Alice has to figure out what X is, and Eve has to figure out what X and Y are. And it's just that much easier to solve one variable than 2. That's basically what it comes down to. And now when they solve the problem, Bob and Alice figure it out in a second. It's 128 bits long. They start using it for this session. Eve figures it out too eventually in 2065. but then so that's why for that session they make session keys. Follow this so far? Pretty simple. Anybody see a vulnerability here? What could go wrong in this scenario? I got buddies in my band from the neighborhood. Don't know nothing about no computers or nothing. But my drummer
still
was
man in the middle, right? Sorry. I mean, interrupt your analogy.
no. Kim, thank you so much for sharing your camera, brother. Appreciate it. I could just hear my brother, my brother Henry, and he's the one I've known the longest. We lived on the block since he was born, and he's 18 months younger than I am. He would go, dude, I bet you could mess somebody up. So how, if she never met him, when he yells out 7, how does she know that's really him? I bet you could go into the Starbucks, right? And just say, hey, I'm Bob. Here's a number. They ain't going to know. And I'll do the same thing to Alice and vice versa. The problem is the asymmetric key, the public key, isn't signed. These Diffie-Hellman keys are not really signed. What is the likelihood on the internet of that really happening at the exact moment? It's pretty low. So it's not really that bad a way to do because the key is ephemeral. It's only going to last for a little bit, and it's so quick, that thing. So it's not really a bad protocol, Diffie-Hellman. It is common knowledge that it's vulnerable to a man-in-the-middle attack. But so would this be. The reason they went elliptical curve is just because it's a lot faster, a lot more efficient than Diffie-Hellman, really. But it can't sign. It can encrypt hashes. It's not like that. It's not a long term. When you get an RSA key, it's good for a few years. When you get a passport, it's good for 4 years, 8 years. When you get a driver's license, it's good for X amount of years. Your RSA identity key, they don't make you do that every session. So that's what they use for signing. Well, you could do that on elliptical curve as well. That's called elliptical curve digital signature. This is what Bitcoin uses. Bitcoin uses ECDSA to encrypt a SHA-256. That's right. Your Bitcoin's only good till 2065, man. You better start preparing now. My order of operations, that worry is not there. All right. So we're going to watch for this as we go through this crypto. They know that all crypto systems can do up to this stuff. But what are crypto systems and what are the ones we're going to probably care about? Well, this is TLS, formerly known as SSL. Just newer versions. A lot of admins use a completely different tool. We used to use Telnet to communicate to our devices. Today, we're not communicating to our devices today. We're probably communicating in a bigger network to some controller in a software-defined network, but it's still got to talk to those devices. And those are frequently over SSH. SSH can do a lot of stuff. SSH can do a lot, yeah. TLS, requires PKI. That means you have to have a certificate authority somewhere involved at the root signed, probably some intermediate that signed every X.500 entity that you connect to with a certificate. SSH can work with PKI, but most common, at least in my experience, is just a passphrase. We'll say equals a passphrase. And that's a lot cheaper. I mean, if I'm just, why do I need a certificate to, passport if I'm just administering my devices inside? It's not wrong. Just watch out that SSH is used really, proliferately for admins. You can't turn it off. You need it. But at the same time, it's a very common, because of that passphrase and no requirement, the way that hackers love to, especially botnets, and backdoors through your network. So it makes a great covert channel. It's really hard to sniff out encrypted traffic. And just because it's defaults to port 22, you can run it on any port you want. So you can't really, it's one of our biggest covert channels. What was the SSH? No, you can. That's why I say it can work with PKI, and that's a common myth that SSH can't work with PKI. No, thank you for pointing that out. The other encryptions, everybody does Wi-Fi. WPA, hopefully WPA2 and better, but Wi-Fi. We'll just say Wi-Fi. And this is just a layer 2 only, and it's only local, only. So that's just me to my access. We also have IPsec. IPsec is at layer 3. And it can do a lot of stuff, in theory. But there are some weird things that, I don't know. Did anybody see all the impetus for the government asking people to start using encrypted services during December? Kim, did you had to see that? You deal with CISSP requirements, right?
Which type of requirements?
There was a whole bunch of news, and I'll pull it up, about the CISA asking people in the FBI to stop using particularly clear text SMS and to go to apps like WhatsApp and Signal. And I'm like, isn't that funny? Isn't that funny? Because Phil Zimmerman, especially if you know the story, who wrote PGP, they made him a bad guy. He gave the world free encryption. PGP was a gift to humanity by Phil Zimmerman to give the average everyday man NSA level encryption. And they fought him, and he said, "You're not allowed to sell that." And they took him to court, and he lost, but he was allowed to give it away. If you don't, right, Marcus? If you ask the wrong question, the answers don't matter. So he released it. And they made him a bad guy. In movies like Sneakers and stuff, he was a bad guy. But now, CISA encourage encryption.
Hey, Larry, I'm gonna try to get this out because my Wi-Fi is bad. But basically, it was about the texting between Apple and Android users, sending stuff in clear text. So they're telling everybody to start using Signal and WhatsApp.
But is it
Personally, I think they try to push you toward the encryption so they can get into your stuff too. But if everybody's using it, that means they can also get into it, I think.
It's like at first they said, "Give us your guns, give us your guns," and I was like, "Everybody, get armed, get armed." But it's a good armament. It's not one that's going to hurt anybody. It's just going to protect us. I mean, it might slow things down, and we'll figure that out. But I'd much rather solve problems with numbers than with bullets, But yeah, they're encouraging it, and I love it. Yeah. Hey, you know what? Everyone got to try their best and see things, but it's hard to keep up with the development of AI. I'm sorry. The government in every country is wrestling with how do they control AI, and I'm rolling my eyes like you got as much luck as controlling my go-kart. But I'm very hopeful that in 2029 post, it learns to control itself better than any human would anyway. We won't have as many sugary foods because we're just stupid about a lot of things. But until then, it's going to require some heroes like us to protect the common good. All right. So these asymmetric algorithms, remember, are bound to the person and very testable. And now in FIPS, speaking of encouraging us, is the post-quantum concept. So remember let me clear this up. Quantum threats, if they ever come about, are based on what's known as Shor's algorithm, who proved that it's like what I just said, it's easier to solve one variable than it is two. They said, no, with quantum, it would be just as easy. And if that's freaky to you, you're in good company. Einstein had a problem with quantum theory. So I don't want to convince anybody that quantum theory is real. I'll just say that they've worked on it. Nothing to fear. They went through the thing 4 rounds before they selected them. But as of 2022, we have selected algorithms. And it's just the asymmetric algorithms. That's the public key encryption, the key establishment, Diffie-Hellman, and you could use RSA, you could do that as well. Elliptical curve Diffie-Hellman, whatever. And the digital signature atom, RSA and elliptical curve DSA. They're the ones that are going away. And they selected, for key agreement, they only selected one, crystals. Now, there is a big open SSH, people hated that. So the same people that make this Falcon and True, which this was fine with using them for a signing algorithm, they also have a key establishment. I think it's called N-True Crypt. And they whatever. SSH does not default to Crystal's Kyber that I know of. Who cares? Whatever. But bottom takeaway, only the asymmetric algorithms are affected. And we have a solution. We've had one for years now. Okay? So nothing to fret. It's just the fact that 1, we probably don't need them. And 2, laws and regulations are going to require that we roll it out anyway. But we're going to maintain the AES. And on every exam, every practice exam I generate, it's called hybrid encryption. The answer is to roll out hybrid encryption. Okay. So I guess with hybrid just means I still use symmetric for data, but I use asymmetric. I'll give you one last note on this. For those techie enough who are trying to struggle, but that's not what I read about asymmetric. I heard you can encrypt data with it. Public key encryption and key establishment. Over here, it was public key encryption. And then they changed it somewhere where it was just key establishment. And then it came back as both. I've never seen anything get encrypted with a public key that wasn't a symmetric key. But I can argue for a reason why you might want to. In tokenization. Suppose I have a tokenization of a particular social security number and it's a fixed length. It's going to be a SHA-2, whatever, 256-bit hash. It's not big data. It's a fixed length value. And it's no bigger than any other hash that I sign. So I could see that in the future. In databases, if you're doing development and you're thinking about these concepts, Larry, I heard you could, I could absolutely see why that would work for fixed length values, like any token or a social security number. It's fixed length value. So let's keep an open mind there, but remember the reality. The reality is the only thing you encrypt with an asymmetric public key is a symmetric key to share the key. And the only thing you encrypt asymmetrically with your private key is a hash, and that's signing. Key agreement and signing, post-quantum, we got it. All right, so our definition, we use these mathematical yada yada, we encrypt, blah, 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 we have random numbers. When you make up a key, when Diffie-Hellman, and Bob and Alice come up with a 256-bit key, I hope it isn't password 123. It should be a random number. Will the test bring up today how safeguarding unprotected once they might? So what's let's say I encrypted my hard drive. If I encrypted like a TLS session versus my hard drive, since you brought it up, if I encrypted a TLS session, did somebody capture that? Did somebody go to the ISC2 or whatever, get a man in the middle, capture the traffic between maybe whatever, me and say Amazon, get my credit card number, and then in 2065, or let's say 5 years from now, quantum cracks that. What are they going to do with that data? But if it was a disk, if it was archived important data, a year's worth of whatever US Treasury data, and it was encrypted with this session key, that was encrypted with whatever the Treasury admin's public key, and they crack it, they get all that data. So if it's data at rest, like in archive data, they could get that. We have to weigh out the risk. In a TLS session, I don't find it reasonable. In an archive data, I absolutely find it reasonable. That makes sense?
Yeah, it does. I hear it all the time from. I see it as marketing, and I understand that there is risk, but it's kind of like because I'm in sales and I can understand it and I respect it and I do think there is risk, but I was curious about your take on it because like it apply the level of security for the level of asset and what the risk you want to accept with it, right? So I guess if you want to put a post quantum safe algorithm on the Treasury's main server that has some archive data, then yeah, that might be applicable. But like you said, a regular TLS session, not a big deal.
I'll bet you would appreciate this. This is my real angle. I think the risk is extremely low of an actual exploit. The risk of a performance hit from going at least from RSA to post quantum, you might get better performance. And the type of audience that would bring me in to do that is likely to cater lunch. It's supposed to be a really nice environment. I bet you they would have like the killer sandwiches and the Starbucks coffee. Not just like, oh, there's our cafeteria. Awesome place to work. Now, I'm supporting this. Hey, as long as you should go, I mean, what's it going to cost you? It's going to be a little bit faster, and whatever my services cost, and I'm going to enjoy this. I enjoy getting paid.
Cool.
Well,
Thanks for that.
thank you again for turning on your camera and doing that. I was telling my wife about your background. It's great. All right, so we know we use symmetric for the data, asymmetric to whatever, to identify with somebody's person. So who got the symmetric key or who signed the hash, right? And the applications are many. We need to give in our trust principle. We already said we're going to use privacy by design. So when people go, "Oh, well, I didn't know you needed to encrypt that data," well, why didn't you encrypt the data? The only reason I wouldn't encrypt something is because the header need to be read by some intermediate device. Otherwise, I'd encrypt everything. As a packet analyst, do know that I can always see some packet header that you can encrypt. You can encrypt the frame header. If it goes beyond your router, you can't encrypt the packet header. And most of the time, there's a TCP or UDP header behind it that you can't encrypt there either. So I can see something. I can't see what you're doing in there, but I can see the people keep driving up to your house at 1 o'clock and stay for 5 minutes and then drive away. And I go, something funky going on over there. And that very testable concept is called traffic analysis. Please know that whether you're doing it for IDS or you're trying to evade something, whatever, you think something's private. People don't need to know the content of your call. If they can see who you're calling, that already tells us a lot of stuff. So that's how we can totally catch most botnets, right? Most botnets are encrypted most of the time over SSH. But you just start watching traffic patterns. In my environment, clients talk to servers. That's just how it works. I don't need to go beyond that. I start seeing TCP resets from clients. And I go, why is somebody trying to hit a client to client? That's not right. So again, we can encrypt data at rest. We can encrypt data in transit. Sometimes for some types of data, we might be able to encrypt in processing, but it's very difficult. So that's as we protect data, right, at rest, in transit, and in processing, we know that processing is the most difficult. The hardest part is not making strong algorithms. The hardest part is key management. And that goes from anything of you not making up a strong password, if your passphrase is passphrase 123 or whatever, but it's also rotating the keys properly. It's not storing the key in a section of RAM that somebody else could get to, like the way Heartbleed did, And sometimes we call those implementation attacks. Rarely today is it a algorithmic attack. It's almost always an implementation attack. Yeah, they just tape the key under the keyboard. WEP was cracked not just because it used RC4. Really, it wasn't really the RC4's fault. It was a 40-bit cipher. It was kind of weird that they chose a 40-bit when we were phasing out, a 56-bit DES, but whatever. That's not what made it bad. It was other implementation things that just made WEP laughably bad.
You should be familiar with why web was bad. Just make sure you understand what were the key weaknesses. And then, Larry, I think we'll cover that in networking, though, in detail.
What did you say? You want to say? You want to give me an example of one thing that's really bad? And I think it's an important concept, and maybe I think everybody can get it pretty easily. When we use
initialize, yeah, go ahead.
Yeah. Well, no, I wasn't going to get to the initialization vector. All right, I'll tie that in. But when we use a key, like a password or something, that just opens the door. That's not the same key I use to encrypt the data, right? I might use something else. Like when I use my passphrase on my WPA router, we all use that passphrase. We're running personal mode. And that's how we get in there. But then they generate some random number for each of us. So I can't turn on my Wireshark and decrypt your data, even though we're on the same network, same passphrase, because they use a different key to authenticate than they did to data encryption. So, but WEP used the same key. So that means if I know the key to get to the company, Wi-Fi, I can sniff everybody's data. It never changed. So that's insane. That alone. Now, how do they do this? You mentioned the authentication itself with their famous use of an initialization vector. So it's testable and it's very pertinent because we're going to talk about initialization vectors here anyway. All right, so a client has his workstation and he wants to authenticate to an access point. And they're using WEP, so that means they have a shared secret. It's symmetric. So they both have to know the WEP key. I'll just draw a black key here real quick. I was supposed to be black. Order of operations. So he's got this secret WEP key, and they know it. And Eve is eavesdropping. Eve is always red. Hi, I'd like to authenticate with you. In clear text, red is clear. Oh, yeah? Prove to us that you know this key. How? We've got this little random number generator that somebody built in for us for some other purpose. We'll use it for this purpose. It's called an initialization vector. That's not what IVs are supposed to be used for. Initialization vectors are, think of a puzzle, and you have a 40-piece puzzle, right? There's 40 pieces in this puzzle, and you don't even have a picture of the box of what it used to look like. You've got to put these puzzle pieces together, and you don't know what you're putting together. And you could brute force them. Does this piece get it? That's what a brute force attack does. But you'll probably notice a pattern. All the flat pieces go to edges. You'll do pattern recognition. All these green pieces go together somewhere. And eventually you'll figure it out. I don't care what encryption you use, somebody eventually could brute force, or worse, find a pattern. That's a side channel attack. Right? It didn't have to guess every value. I found something else. You always start with the answer B. So that's what the purpose of the initialization vector is in WEP. It was supposed to add more pieces to the puzzle. It's 24 bits. They had a 24-bit initialization vector. Its purpose is encryption, is to just make it harder for the person to do the brute force it or pattern, because they're like, I wonder where this piece goes. And it's like, nowhere, sucker. Ain't got nothing to do with it. But they decided to use it for this feature. Okay. Eve listens to this and she hears the plain text of 24. That's the picture on the box before, right? And they say, take this 24-bit, encrypt it with that key, and send it back to us, now in black text. And she gets both versions. She has the 24 of the picture on the box of what the puzzle's supposed to look like, and she has the puzzle pieces. She does a known plain text. It's only 24 bits. My phone can do that in a second. She does a known plain text attack against it. She grabs the key in one packet. They actually never let that out. That never really came out. It was so bad as they were in testing, but they wanted to release it. And that used to be a test question. WEP started out with this horrible shared key authentication and later moved to, never mind, don't do that, run away, open key authentication. They just let you on. But they didn't, you still needed to have the WEP key to encrypt the data. So, and it used to be a test question to know that OKA, open, was better than shared. And that just seemed, counterintuitive. But it's just bad from so many things. And 24 bits just isn't long enough. So it used to be testable to know one of the things that WPA fixed was made it 48 bits. In anything, I don't care what number that anybody gives you. Why did you make something longer? To make it harder to guess? That's all you want to think. And that's known as entropy. Gave it more entropy. It's harder to guess.
But Larry, there's so many other things you could do, right, to protect the layers. So it's not just, okay, yeah, they could go to the equipment, but if you have other layers of protection, it'll be still difficult.
Well, in anything, right? We always look at the operating.
Yeah, that's what I mean. You're talking about a home user. Yeah, okay, I could go and hack my neighbor, this and that. But if you're going into an environment, into a corporation, it's not going to be that easy. If they set it up, huh?
WEP is gone. That protocol better not be used.
No, not WEP. I'm just saying in general, like that's why they talk about layers of protection, right? If
Sure.
it gets into one layer, it's going to be harder to get to the next layer and the next, right? So
Absolutely, absolutely. When they did have to do WEP in the military, to your point, and there wasn't a counter thing, they also did things like Faraday cage type things. Like, have you ever been in a building that's cleared to top secret? That building's in a Faraday cage. Eve's not sitting outside that building and sniffing out that key. And if you're using it in communication outside, they would use, in fact, I have to tell my students and say, you could use signal jammers and noise generators. And I was like, you better be the military if you're doing that, because they're illegal for private citizens. But yeah, they would do stuff like that to create these only trusted zones. So your point is very good takeaway. Whenever we have something, if we needed to still support something that is vulnerable, you create layers of contingencies around it, compensating controls. Is that what you were trying to drive at?
yeah. And that's why, yes, and that's why a lot of bad things happen, because those layers of controlled aren't being addressed properly and people get in. That's
Well, because people like Larry, who are supposed to be washing the dishes, are dreaming about that gig Friday night.
you're
I
dreaming about your
But the
guitar.
answer to looks like Larry wasn't paying attention. That's probably the right answer. That's who my wife hits me. I heard, by the way, my wife has a colleague in this class, and I don't know who you are, so I better be on my best behavior. Say, hey, don't talk about any proprietary stuff. I already talked about some CrowdStrike stuff, but I hope I gave away no real.
I'm not sure you saw Robert. Is that you? You waved your
That's
hand
me.
there.
Oh, there you
Yes.
go.
Larry, you better
Formerly,
behave.
yeah, formerly in the cybersecurity group, now in legal, handling global privacy. But yeah, same company. And yes, notice I didn't ring in on any of the CrowdStrike stuff yesterday. I just kept my mouth shut.
Well, I hope, and I didn't say the company name
You
or anything, right?
no, you didn't disclose anything. No, it's
That's
all
all
good.
right. We know all about it. CrowdStrike and Microsoft
She was
together.
so adamant, and again reminding me just before I got started, and don't say anything about company name. I don't. You know,
No, you didn't. Nope, haven't up to this point. So yeah, no, you're all good.
Larry, you'll have to switch your other stories and pick on somebody else for domain 7, I guess.
Well, she always gets the ultimate respect. Again, I always say she's the one that says, if you need somebody to talk, you can get Larry. He's good at that. But if you need somebody to actually do the job, get it done on schedule, on budget, you're going to hire me. And I will admit that that is absolutely true. And I'll bet
I concur.
she's a great project manager, and nobody's going to bull her technically either.
Exactly. She really is best of both worlds. So that she's a very valuable asset here.
Awesome. Well, I didn't even notice you had your camera on. Thank you so much, Robert.
Yep.
All right. We're not going to admit to her that you were so nice about this. Thank you.
No. You tell her whatever you need to say about me. That's not a problem.
No, it's me I'm worried about getting in trouble. Why did you even do that? I don't care if she gets you in trouble. No. All right. So again, remember that it's not the algorithms that likely get cracked. They want you to know that the quantum might crack them. I'm not really worried, but it's usually a key, some implementation problem. It's just like passwords. You got to make up a strong password. You got to use them properly and change them regularly.
Wait. Now, is it true, Larry? Because you brought up password. It's not how long, it's how, what is it? It's the keys, right? It's the type of symbols or in keys combination that you use, right? It's not about how, because you can have a long one and it's not
I'm
strong.
going to bring up my favorite document on this. You bring up a great thing, and I want, and for those who are curious, I've had students tell me that they spent the morning drinking coffee before the exam looking at this document and saying, "Oh, dude, you have to tell your students to read this. It's just not the entire document, just the glossary of terminologies, and the term you're looking for is entropy." So we want the digital identity guidelines. That's 863-3. It's my favorite. Almost all of these documents have some glossary, but look, it's already right there. The soul. So you're looking for. Look at already great stuff. In fact, it's a great one that'll lead us into our next areas. We're looking for entropy. What really matters is how much entropy the uncertainty of an attacker faces to determine the value of a key, right? Of a secret value of the secret. It's usually stated in bits. So if I have 1 bit of entropy, they have to guess, is it 0 or 1? If I have 2 bits of entropy, then it doubles. It could be 0, 0. It could be 0, 1. It could be 1, 0. It could be 1, 0. We usually type things in a system 8 bits at a time. When you type in any letter, the ASCII Federation Standard US key code that is now a Federation ISO key agreement presentation layer standard says it's got to be in at least 8 bits. But the ASCII characters, how many letters do we have in the alphabet? 26. So if your password is only lowercase text, you're not getting 8 bits of entropy per character. You're getting, which would give you 256. 8 bits gives you 256 values. Everybody who does subnetting knows that, right? 8 bits of subnet, I get 256 more hosts. So I would think that my password has, 8 bits of entropy, but it doesn't. The full ASCII key set is upper, lower, numeric, and special characters. That will give you an entropy, I think, of 96. Because when they made up the ASCII key set, they made up upper and lower. That would be 52. Then I add numbers, 62. Then I add a couple more. But there's some things that we don't type in, like carriage return. And it's only really 7 bits. The ASCII only asks for 7 bits. You can do whatever you want with that 8th bit. Everybody uses it for error checking, parity. That's why if you look at the old books and they talk about DES only using whatever, giving you 56 as opposed to its 64-bit block, because the assumption was you were typing ASCII. But in my day, when I started breaking in computers in the 80s, they made the IBM PC. And with this Bill Gates making with the software there, they allowed you to have in the hardware of the system 9 bits, 8 bits for ASCII, and a 9th bit for parity. So now they created what's called the IBM Extended ASCII key set. I'm going to tell you a funny story here. I know we're going a little bit here, but I hope this really helps. It's great, the story of a great hacker I was just thinking today. So the Extended ASCII added another bit. Now, I was wrong. I said 95. It's 96. You could only have 96. And here it's like, we add another bit. And this is when you see things like these. This is the Extended ASCII. So ASCII code 128. Let me get something that could type it out. WordPad. So if I hold down the number and I hit the number pad 128, I get that weird thing. You could put that in your password. That makes the entropy of your password way harder. Now I get 8 bits of entropy. You're not as good. It's going to be much harder to brute force this password. But it was really cool when I first learned this from a great hacker, and I can't find him. I only know his first name, Mike. It was in the 90s and we worked together. He was so funny, but he said, you hold down Alt and put 255 and you get a space. And he says, even if they have some tool that can reveal the password, the person might not notice the space. You put it at the end of your password. And I was teaching for a company called Icon. So I made my password, EYE, lowercase, special characters, ampersand, capital K, number, lowercase n, and then Alt 255. Because you got to have at least 8 characters those days. And then I have to teach my very first class, a Windows NT 351 workstation. And on like Wednesday or something, the guy goes, damn, what's your password? What? And he goes, you ever see Lofcrack? No. He's been running a password cracker since Monday. He said, I had everybody's password Monday morning, like 10 o'clock, but yours. Write this down. I use his password for everything. No one will guess it for you. No, it just adds the entropy of that. Does that make sense now?
Yes, that's what I'm talking about. Doesn't matter how long, you got to make
Yeah, it doesn't. If you did this,
variation of what you're talking about, because that was an exam question I had on my Sec Plus.
That's right. That's why if you only use lowercase, you really greatly reduce the entropy of the possible numbers. But people remember that. So that's why a passphrase, in theory, if I make it, well, take into account what would 8 bits of entropy times 8 characters give me versus how many lowercase text would I need. Let's not make it a more complex that people are likely to write down. Let them write up a phrase that works that way. But as Bruce Schneier pointed out, The English language doesn't have that much entropy. On an exam, passphrases are just as good as complex passwords, but they're easier to remember so the user doesn't write it down. But if you see T and it's a 3-letter word, I'll bet you the next 2 letters are H and E or something. We don't really have that type of entropy there. It's hard to say for sure. I don't know what the right answer is, other than I love randomly generated private public key pairs and my private key stored in hardware on my FIDO keychain on my Windows Hello. I now trust my Android for now. Haven't heard anything bad about their secure enclave or my iPhone. So far, I haven't heard of any of those getting their private keys hacked. Every TPM type kind of hack has always been, we got a session key. And in which case, kind of like your question, Paul, if quantum works, what would it do? In that case, they cracked the session key and they were able to get BitLocker encrypted drives. But nobody gets the private key as far as I know. That's true when you're on your CAC. That's true on your smart card. Your smart card has a secure. Your Visa and MasterCard. That's what makes them smart. That and the ability to process other people's hashes. Yeah, well, this is my X.509 card. And you go, oh, yeah.
Larry, thank you for sharing. I love that. Thanks.
Cool. Thank you for asking. Once again, I really appreciate everybody who's being active in the class. It really, really helps. So I don't think I'm just, I don't know, did they enjoy it? Nobody said anything. We talked about these deployments, right? With the shared security model, absolutely distributed systems. So we did cover a lot of this. We must have been, okay, yeah, IoT stuff and how it's everywhere. There was a great hack at DEF CON, Black Hat DEF CON. My wife, Robert, will back me up, gets to go. She's going every year, and I never get to go. That's when I stay home with the kids. But there was one year when someone broke into the hotel network by a smart thermometer in a fish tank. Look it up. It's a very funny story. Yeah.
And never use the ATMs within 3 blocks. That's the rule, right?
What's that?
Never use the ATMs or any Wi-Fi within 3 blocks of the hotel.
If it's got a tap on it, I'm still trusting. Has anyone ever grabbed the tap? I don't trust anything that's vulnerable to a skipper. I definitely get paranoid there. But on the tap one, I haven't heard anything.
I always try to pull on it to see if it's fake.
I put my finger in there. You know where most
Yeah.
gas stations that you're like, why are you still a magnetic reader? Wasn't this supposed to be going away 10 years ago? Yeah. Anyway, we talked about the microservices again. Today's applications are like developing a sandwich shop developing your restaurant food at like a Subway sandwich shop. You're just responsible. You focus on one thing. Everybody's good at one thing. As we work through this world of collaboration, let the tea come from China. Let the sugar come from the Americas. We don't really like sugar anymore. I switched to honey.
You know what I hate about restaurants? Why are they allowed to take your credit card? I mean, they can steal it. They steal your freaking number. I'm like, they take it in the back. I don't know what they're doing in the back.
That's the first night I talked about that. He said, oh, we should be breaking here. Yeah, let me break it in. Let me break. Hold on. Pause the recording.
Larry,
tomorrow. All right. So again, when people develop applications, there you are, Arpita. We're just waiting for you to take the picture again. Let me pause. There we go.
Oh, I'm so sorry.
All right. So we know, again, when we develop apps today, you probably just develop or piecing together components, just like if you're a restaurant, you didn't make everything. You don't have cows back there to make the milk. You use suppliers. This is why supply chain management is so important. These supplies are APIs. Hey, right. So we watch out for that. Yeah, it's API security. And thank you again, it was Paul, for bringing up MTLS. I'm going to admit I didn't know that protocol, but I certainly always talk about mutual authentication and the vulnerabilities that it mitigates, any man in the middle. So what he pointed out is that apparently the cutting edge of, and you didn't even say in that context, I hope you give me credit for immediately wanting to apply it to OpenID, and it works. So using TLS, which requires PKI certificates. When I went to the ISC2, they gave me their certificate. I didn't have to give a certificate, but it looks like the cutting edge of securing API, the identity key is not a certificate. It's an encrypted token, like a Java web token or something like that. And it's going to be signed. It's a signed token token for open ID. That's how an API can identify itself in an open standard. And they can do it, negotiate it now with the protocol that Paul brought up, mutual transport layer security. So unlike me going to whatever Amazon and or Zoom for this thing, and they gave me their certificate, I would need a certificate too. That sounds like a great countermeasure to the API's problems we're having. I like it. I like it. Thank you so much for bringing it up. It was you, Ross. I'm sorry, yeah, but MTLS could be applied in all sessions, right? I could see it in all kinds of wireless communication. I could see it in negotiating because 5G didn't come out, right? They tried to do the other one, EAP TLS. EAP TLS is kind of hard to roll out. And I could see this as a, in fact, let's ask that if you don't mind me digressing, because I think that's an important thing. ETLS didn't, and I thought as a counter of TTLS. Let me see something. Actually, I'll ask Claude. It won't likely hallucinate. We'll see. Can MTLS be used instead of EAP TLS in 5G? Is it because, oh, wait, 5G needs a network layer 2 connection. That's why it needs the AP. Oh, hold on. Is it safe to say, EAP TLS is at layer 2 and MTLS is more transport or even app layer. Oops. Come on, Larry. App layer. That's exactly right. And we know, I mentioned that earlier, that's part of Zero Trust. So I'll bet you MTLS way more supports that Zero Trust model. So I don't have to give you any, right? It's just, okay. All right. Ross, thank you again. Very grateful to have you in class and your contribution. All right, containerization. We talked about this yesterday. I don't have to create a new virtual machine for everything. That's a lot of overhead, a lot of network stuff. Let's just contain the application and any so-called shared DLLs that the OS would have in the kernel and contain that part of the kernel. So same user database, same hardware database. Don't do anything. Just plug in a container and you could use somebody else's stuff. That's how a lot of AI services from your provider. That's how, if you get Azure machine learning or AWS stuff, they're giving you containers to plug in. Really nice. Now, a couple of risks that I do remember being considered, escape vulnerabilities. Just like we talked about hypervisor attacks that I cross over and hyperjack over from one guest OS to another. Could you do the same thing in a container? The container image, where are you getting it from? A lot of web servers today to mitigate some persistent error. Like remember I said, like if I go to Walmart.com and they ask me for my social security number or excuse me, my zip code so they can customize it for that session. And they keep that in there. And through some cross-site script, someone poisons that memory. They actually just re-image that server constantly. They're constantly rebuilding, but they won't want to rebuild with an older thing. There might be a new in the DevOps, agile model, a new one that rolled out, and we have to maintain a signed log, and orchestrated. And Arpita can explain that a lot better on day 5 or day 4 if we get there. When we get to app security. Right, embedded systems. This is the stuff embedded in hardware, and can be like one of my favorite ever embedded attacks. I remember I was teaching when it came out. It was so funny because it was for a DoD internal, and it made them. I think it was like Thanksgiving or something. There was some holiday that they had to work because of this. And the funny part is because it was sold mostly at Best Buy, but it was a digital picture frame that had embedded malware in it. The gift that keeps giving because it was really crafty. The the malware exploited Microsoft and a Mac's auto plug and play. You plug in a USB thing, you didn't have to, find the driver from the manufacturer. The operating sees some signature, pulls down the driver, and so it's plug and play. And in order for a driver to run, it's got to run in zero kernel mode. So this driver that you just plug and played, that grandma did, it's a digital picture frame that you would give people so you put in this whatever camera and they could just keep changing images on the picture frame. And so, boom, immediately affected. Not only did it infect it at a kernel level, but this was why it kept giving. Anything that you plugged in later that had a drive letter. So if you plugged in your camera, your external drive, something, and it mounted as D drive, it got it infected too. And then when you shared that with somebody else, it got infected too. It's so awesome. And so that's why when you plug in from XP on, it said, do you want to do this? And that's when you got to run as administrator, right? This thing wants to, that's what that means, So you're very careful about that. But if it's better than, I just assume, like we were talking earlier, these robots and everything else. Ross, I'm accusing my AI of trying to socially engineer me, and I said, look, and no matter what you say, and I'm going with Kurzweil's timeline. I'm not going to believe you until 2029. Just how I roll. All right, cool with that. All right. So, but it is cool. I mean, everything comes smart. You got to trust these things. High performance computing systems that went over yesterday. These are just like really high speed abilities for networks and stuff for CPUs to talk to each other. And they're paralleling all these giant CPUs for ChatGPT to run. Some of the most that in Bitcoin. But think how Bitcoin works. Totally distributed computer, and no one person owns it in the data center. Bitcoin proves you can run the most powerful algorithms on a decentralized network. So I'm really into that concept. But anyway, but there are some things about understanding how these high-speed networks work. All right, virtualization. We talked about this before. I mentioned that my VirtualBox is a Type 2 hypervisor, because I have to run it on top of, in my case, my Windows 11 operating system. And it's only because Zoom runs better in a host of Windows. That's the only reason. Otherwise, I'd be running this in my Mint Linux. It's my favorite little fun host. But anyway, when you're going to cloud computing, your Hyper-V, whatever, VMware, they're big servers. They're just bare metal. They run directly on the hardware. It's common knowledge. These are much simpler, much easier to secure. Fewer parts to, you go to one vendor for the patches. We trust them. Oh, we didn't see that. A large enterprise is implementing containerization for their microservices architecture. Which of the following is the most critical security concern to address?
Are they trying to ask if we know what container versus microservices is? Because
No, I think you look at the 4 answers on the menu and you go, what the hell is this customer asking me? Most critical of these four? And I think everybody's getting it because I don't see how network latency is going to be real. I mean, maybe are the microservices running on different machines? Are they on the same machine? We're going to talk about software-defined networking, and in
Well,
yeah,
I'm sorry, go ahead. I was going to say B, C, and D are kind of the reasons why you would use microservices. Like those are all net benefits of using.
right. That's another one. That's another thing. Which of these
Not
is
unless you configure it properly, because there's other security issues if you don't.
That's true. Yeah.
No, it's definitely making sure that as you're re-imaging and stuff, and you're bringing these
Yeah.
bits that they're signed because you generally get these from other vendors a lot, and to be part of your app.
Yeah.
In fact, my favorite DevOps person, DevSecOps person, she talks about something I haven't seen on the exam or any practice thing, but unikernels. A unikernel, she thinks you shouldn't, like when we talk about, you might see it on your exam, about multi-tenancy.
Mhm.
Multi-tenancy in an ISC2 simple exam perspective is, say, Coca-Cola and Pepsi having their virtual machines under the same hypervisor. But multi-tenancy to some developers, and this woman I respect so much, she says, no, that's running any multiple microservices in the same kernel. So she thinks the future is unikernels. Hey, unikernel. Where it's a machine image that contains everything that's in one little OS component. Unikernels versus containers. So let me see, container architecture, kernel, multiple containers. This is a separate kernel for every thing. It gives you more isolation. I could see where it'd be slower, but she doesn't trust the kernels. These are the ring 0. This is the ring, ring 3. This is the admin level. I run this as root or whatever. Actually, there's a difference between root and what's a big difference between root and admin? Anybody know? Very, very important in security. It applies to our controls and how we could prevent, detect, and respond. We know that if I give somebody the key to my car, I can't prevent them from going in. So I could have detective controls. Maybe I check the mileage. Maybe I have a camera. Whatever you can't prevent, I can't prevent fire. So all of them, I do my best. So I have smoke detectors. All right, admin. I can't prevent neither admin or root from taking ownership of my folder and looking at my folder, the CEO, because this is just like a network admin. They can't prevent that. Windows kernel will always log the admin's thing. You can always say, let me detect what they did. Root to backdoor. You're just in ghost mode. You just tiptoe through the whole place. So that's a big difference. Actually, it's SC Linux. My Fedora does allow you to prohibit root. You can SC Linux labels are applied to root. If they're not given permission, they're not allowed to change those labels.
Right.
But late attack, if
By
it's
default?
huh?
Is that by default, or do you have to put in restrictions
No,
at root
that's
level?
I'm pretty sure that's the
Nice.
default.
Oh, that's
Yeah,
pretty cool.
yeah. But if you the difference is though, if you're like if you ever work on a Cisco router and if you have physical access, you could just reset the damn thing. You could
Mm.
do you could as root, you could interrupt the boot process and turn these SC Linux to just logging. Say do not enforce. And then it's oh never mind. So if they have physical access, but it prevents remote access unless they could whatever initiate. No, it's kind of hard to do that anyway. All right, so I don't know if they talk about unikernels. Unikernels are important, but containers and they go together with that. Containers are very lightweight compared to a virtual machine. But we got to make sure that a container we're talking to, is that really the Uber driver who showed up, or is that a weird guy who heard me call for an Uber and just came up to my door?
Could be Captain Larry.
It could be Captain May. But he's a noble pirate. One of my favorite lines in there is about central management versus decentralized. He gets arrested for as a doctor tending to a wounded man. That's all he knew. And it turns out he was a rebel fighting against the king, who was considered a corrupt king at the time. And the guy goes, all I know is I was doing my duty as a doctor. And he says, don't you understand your duty to your king? And he said, I thought my duty was to the common man. And he gets thrown in jail for that. I love it. Becomes a pirate. Arr. I love that movie.
You think everything needs to be centralized? I don't.
No, I think we're definitely a hybrid. In fact, I think our ID,
Yeah.
my ID card
Yeah.
should be what Larry claims it is. But for instance, my real name is Howard. I will not get my LinkedIn ID verified because they want to use Howard. No one's ever called me Howard. That was just my mom appeasing to the Jewish side that when my grandfather died, we'll name him after him. But I was to be named after her father, Lawrence Joseph Sullivan. And that was always called Larry. And I admired my pop-up Larry. He was the greatest gentleman I ever knew. All right. A cloud-based system using infrastructure as a service, which component is most responsible? And the physical, the customer is most responsible? What do we think that is? Money, is that to the last question? Because physical infrastructure, that's the one thing I know. When I go to Azure, I don't have to worry about disks or power supplies or anything. Yeah, just my guest operating system. Yeah, again, if this were my if I were a provider and I had my hypervisor here somewhere. Oh, there it goes. I would be responsible for maintaining these Fedora instances, but I don't have to I don't have to maintain this hypervisor or nothing else.
That question is confusing.
Why? I'm a customer at AWS or Azure, and I'm using their infrastructure. That means, yeah, I don't worry about this.
No, I'm like a privacy person. I worry about the data, but okay.
Yeah, but you don't even have access to data handling, right? Like that, you have to agree to their terms and conditions at like an MSA.
No.
Right.
The customer is always liable for your own data. It doesn't matter where it
No,
sits.
that's a data center. You probably
Yeah, I
read.
know. Yeah.
I keep thinking about you. Why you missed this exam, and I'm sorry I called out something that might indicate an age thing, but I am convinced it's just like the basketball player who got there and you missed the basket for some reason, even though if you weren't under pressure, if no one was watching you, you would nail that basket. So we'll see how that goes. I hope that turns out to be true, but I have a feeling you actually have everything you need technically. It's just performance anxiety. A company is implementing edge computing devices for real-time data processing. Which security concerns should be prioritized? I'm Netflix, and I'm going to push out caching controllers and stuff out in all the various locations that my customers are. No? Yeah, physical vulnerability. You're going to push these out where? You're going to put one in Logan in North Philly with Greeny Grew one? I see that. But you miss somebody over there. It's going to remind me when I was a kid, they used to put the box that controlled like the multiplexer for all the phones on the railroad tracks just behind my house. And my buddy, who's still my recording engineer today, the older musician friend, taught me how to take a phone, two outer brigader clips on it, and go click them and listen to people's phone conversation. I'm 11 years old and I'm hacking phones because it's physically available.
And Larry, I think at the beginning of that question, I was overreading the question because there's only one there that's a primary security concern. And I'm like, network bandwidth security, system performance security. Like, no, only one of them says security. So I'm kind of going with that one.
Oh, that's funny. That's a great pattern there too. Yep. Again, your job is to be a waiter at a restaurant. The question is the customer. You have a menu with only 4 items on it. It's one of those 4. 2 of them are definitely not it. It's the other 2, and you're going to they're both right, but
Larry, do you know the easiest questions everybody gets wrong? It's always like that.
A company is developing IoT devices for smart home automation. Which security vulnerability requires the most immediate attention? Oh, it's wonderful. You know, one of the, and my buddy Tom, my martial arts coach, who I said I'd show you, a 77-year-old man kicked my butt the other day. He helped me out. I was doing some work. I support this small business around here that has closed circuit television in a couple of locations. And I go over one day and I'm trying to figure out why all these cameras went black. And it was weird. It was just like they weren't even turned off. They were like contrast was turned down or whatever, or something like that. And when I called him, I was trying to figure out. I said, "You've worked on this system." He goes, "Oh no, it's a botnet." What? It was Mirai botnet. So a guy who wants to impress people with his hacking skills. He apparently had no motivation for things. I think he's trying to impress Rutgers University is the story. He takes a vulnerability he discovered in Minecraft, some DLL microservice that wasn't just used in Minecraft. It was actually used in almost every closed circuit television system. And he writes this thing that exploits default passwords. It almost brought down the internet. And it mostly exploited closed circuit television system that he never meant to do. And it was all because of default password thing. Mirai. Botnet. I'm spelling it wrong. There you go. Default passwords. It was insane. It was insane. It was all IoT stuff. Just dumb passwords I can hide. I'll show you another one that's pretty fun. Just go to default password list and try spraying that at everybody. You're going to get 20% of the internet, right? Yeah. You know, the hacker's motto is, it's like everybody has an H-bomb. You don't fear anybody. It's like, dude, I could break into you. I don't care who you are, but you also know, and they could break into you too. So do unto others, dude, because you ain't got eyes in the back of your head. Anybody can hack me. Larry, I love your music, sucker. In a microservices architecture, which security vulnerability poses the greatest risk? Those APIs. Again, most entities are not human anymore. It's just going to keep growing. One stat from Peter Diamandis' Abundance, A360 I go to every year. And last year they had an OpenAI, and we're watching it unfold, say that we're looking at a world shortly of 800 billion AI agents. There are only 8 billion people. Peter got it wrong. He goes, so you're looking at 800 million. He goes, no, I said billion. So these are APIs. We got to get them identified. A virtualized environment is experiencing security issues. Which vulnerability should be addressed first? Yeah, you don't want them to escape out of one guest VM and get into say, yeah, also known as a hyperjacking attack. Yep. All right, my favorite part here, we select and determine our cryptographic solutions. We covered so much of this, so we should be able, but please do stop me. I need to know if I'm getting through. Some of you have your camera on, I could very much appreciate, but others, please let me know. So the cryptographic life cycle algorithms, they change. We're probably looking at having to go for no other reason, at least regulatory compliance, to move to post-quantum algorithms, whether it's real or not would probably really, and it probably would speed up RSA anyway, so it's probably not a bad thing. It won't speed up elliptical curves, but also it's the key management stuff. And how long should a session key be? It depends. As we were discussing earlier, Ross and I, if we're archiving data, that session's going to be for as long as that disk is needed. If I'm connecting to, say, a Kerberos network, it's going to create a TGT that allows me to encrypt things for, that TGT for 8 hours. I'm not encrypting the data with that. I'm encrypting requests and stuff. It's my identity key. That lasts for 8 hours. But if I want to get encrypted to traffic to my printer or whatever, they give me a TGT for that, and that's good for 5 minutes. So you decide. You have to look at the risk and reward of anything. Don't over-secure anything. Whenever you do a vulnerability analysis, don't just consider it in a vacuum. Consider it the operating conditions. My television would be destroyed if it got wet, but I don't use it outside. So I didn't ask for a waterproof TV. That would be a lot of extra overhead. If the use condition was outdoors, I would look for a waterproof, and I would spend the extra money. Let's go back here because actually, Ross, you said something that really close to home about the chain of trust. What did you? Is it the term you used?
Yeah, full chain of trust, which is like
The trust.
each. Yeah, yeah.
Let's take a look at what he's talking about here. Is when I went to, let's just pick where I am right now, Google. Where did this certificate come from? It came. Google uses a generic thing. They used to have a separate certificate for every service. There was a mail.google.com, but now they just use a wildcard. And I don't have a problem with that. Personally, as long as
Really?
it's google.com, that's good enough for me because you could sit there and fight internally. It was mail who did it. It wasn't whatever. Dude, you guys fight. So I'm actually fine with that. And I bet you that gives them performance gain. But where did
What?
they get that? Who's their CA? WR2, that's not in my root list. They got it from here. So that's the chain of trust. That's a lot of checking you got to go through. It's a little bit of overhead. And if any one of these is wrong, there's a vulnerability for a man in the middle. This is why decentralized PKI, especially for identity, I think is much more trustworthy. I'm just going to create an encrypted channel because Ross will create an ID card. And just like when I created my Gmail account, they didn't know who I was, but they accepted. I said, I'm Larry Greenblatt, good enough. Then we monitor. Is Ross being abusive? No, he's been great. Whenever I talk to Ross, we're going to negotiate a key agreement. If he shows a history of, hey, I got a record that he broke in here and stole something, I'll revoke that key. I'm not accepting Ross. He could create a new ID and I'll monitor that one. That's self-sovereign identity. And I think that's where we're going in the future. I don't think centrally managed IDs really work for people. They work for servers. So that's the hybrid I look for, Maria. I would like to see centrally managed servers somehow. I want somebody assuring me that we're all agreeing to red light means stop and green light means go, right? I want to make sure, because that would be an awful mess if we didn't all agree to the same thing. But as far as what I'm doing in my car, that's my business. One of the wild card expires. Now you can have an outage across multiple services, sure. But you also have to go to one place to maintain it too. I guess you still have to pull it down. Google's just great, though. I'm sorry. Every sniff I've ever done of their TLS handshake, it's since 2012. They've just been amazing. All TLS, everything.
Yeah, and they're really cost effective too.
Yeah,
If
and
you're
the
using
small
all
ones
your services on
always
Google,
120.
it's good spot. Sorry.
I said they're always 128-bit keys, and that's because that's good enough till 2065. Why do 256? Why slow me down? All right, but the PKI of what we just talked about, the public key infrastructure is how do I tie that name, that X.500 directory name, what you call Active Directory. When you get a certificate, what's also going to be in there, please tell me I have the tool in here. I don't want to have to go to Linux. What the heck is it called now? CA, XCA. Oh, I don't have it on this machine. All right, I'll be able to show you a simple one here, but it's Cleopatra allows me to. Is it not even on this machine? I just got a screenshot. I don't believe this. Never mind. When you create a certificate, an X.509 certificate to verify that that's really whatever this service, there are other attributes. There are attributes like what a domain you might be in. If it's a user, that first name, department, right? Joe, all those things in your Active Directory that you already have. All PKI does is certify that that's true. Everything in your Active Directory is an attribute that can be validated with PKI. And inside your network, it works great. Microsoft first created Kerberos. They thought you had to just symmetrically authenticate. But by 2006, there became all kinds of ways to authenticate in Kerberos with asymmetric keys. Microsoft finally joined, instead of doing their own thing, ADFS or whatever, they now support a Microsoft Certificate Services, and they support the full X.509 format. So it's cool. And that's how we do attribute-based access control. All right. So we talked about the key distribution is whatever, how I use your public key to make sure that only you got the symmetric key and yada, yada, yada. Digital signatures, only your private key must have signed that hash. We have to generate keys that make sense for this application. If I'm just hashing, like a PKI, what am I doing? I'm encrypting a few hashes. That doesn't give Eve a lot of ciphertext to do her analysis on. So your PKI, your RSA or whatever, the certificate, it's good for a couple of years. There's no risk of that. An AES key that you're even if it's just AES, if I'm just encrypting a meg a day versus a gig a day versus a terabyte a day, I have to consider those. How much ciphertext does Eve have access to before she can find something? So that helps us select our key lifetimes. The faster your processing and the more data you're encrypting, the shorter your key lengths. I like this term, cryptographic agility. Some people would lock an algorithm in place. TLS only lets you select up to so many algorithms. We're going to have to modify TLS to get. But I think actually there's a way to embed it. Microsoft said they're going to do it, put those post-quantum algorithms in Edge. I haven't sniffed it yet, but supposedly that's coming in our browser soon. Our cryptographic methods, we know these symmetric for data, yada, yada, yada. We know that asymmetric today is probably, if it's for people, it's going to be RSA. They have DSA in there. DSA was developed by the NSA. It was supposed to be required for FIPS 186. Never was, because it was not a public or open source algorithm. And people are like, if I can't understand what ingredients are in the soup, I'm not going to drink that soup. So the public fought it, and you're allowed to use RSA, an elliptical curve, in FIPS 186. So I've never actually negotiated this. I've never seen it used. It's still out there. Still out there. When I set up PGP, it's one of my selections that lets me pick. I never pick it. But whatever. It is a signing algorithm only. The other takeaway used to be very testable. No, Diffie-Hellman is an asymmetric algorithm, but it can only do key agreement. It can't sign. DSA is an asymmetric algorithm. It can only sign. It can't do key agreement. I hope it's not even a test question. Anything on this slide you need me to go? The public key infrastructure, though, is how do we trust this? This is that hierarchy of roots and subordinates, sometimes called intermediates, actually probably a better term. But I don't have a lot of faith that this is going to hold up much longer. After SolarWinds or us, I don't know if you follow Bruce Schneier, but he's like, burn it down, start over. And I think this is the way to start over. They actually talk about quantum key distribution, and they have for like 20 years. I got to give them credit. This has been, and now it's real. Since 2017, China's doing this. Quantum key distribution is not quantum encryption. I mean, quantum computing. It's not where I got these computers that can do quantum computing. This is the Diffie-Hellman of quantum. And it's based on two things. One, the beauty is, unlike software algorithms that are pseudo-random, this is truly random. But there's something freakier about it that Einstein didn't want to talk about. He put his fingers in his ears, not listening, spooky action at a distance, can't be true, but it's measurable. It's called entanglement, and it's pretty weird. If the speed of light is supposed to be the fastest possible way to travel, the closest star to us, Alpha Centauri, is 4 light years away. So if two things hit each other, meet each other halfway between, and one goes to Alpha Centauri and one comes to me, and I whisper a secret in one's ear, the other one, even if he wanted to tell him the secret, hey, he just said this, that should take 4 years. But they can do it instantly. Sort of. What actually I say, if I say anything, it's going to corrupt the other one. I'll stop it. He'll stop spinning. He stops spinning at the same time. And it's just weird. But what it means is, and this is what China's able to do and demonstrated it, they can negotiate whatever an AES key. It's still going to be symmetric for data. But they can use this to agree on a key. And if anybody guesses that key, it'll break. Okay, if you sniff my password, I'm not supposed to be able to know that. That's a passive attack. If you injected something, that's different. But this makes passive attacks active attacks, and it's bizarre. Don't worry about it. Okay. If Einstein couldn't understand this, I don't expect everybody to grasp this and have to worry about it. Just know it's theoretically perfect key agreement. It makes password guessing or key guessing an active attack, however. Key management, you have to be able to, that's the hardest part, maintaining the keys. Even in if I'm using a hard disk encryption, and we said if they get the key, they get everything. Maybe I want to rotate the keys and say, all right, I'll have whatever, let's make it really big. Actually, I understand in practice, this would be big. I got 12 keys I use per year. January, I use this key. February, I use that key. Because I have to reproduce it. I can't use a new key every month. I got to maintain these keys. Can't get this too complex. I understand the average is 2 keys. 6 months on one key, 6 months on the other, 6 months on one. And if somebody guesses one key, at least they didn't get everything. It's some way to mitigate if somebody figured it out, right? To limit the impact of potential compromises. Key revocation. If you get a driver's license and they revoke it, all they got to do is go to the driver, the DMV, and put down that license is no good. And when a cop pulls you over, they look at your picture. In a certificate, they check the DNS. Hey, is that 167 associated with the ISC2? Yeah, all right. Picture of the face looks like you. And then they check the date, say, has this been expired? No, but not written on there is that the DMV revoked it. So that's when we call, and we talked about this earlier. Don't give me a list of every revoked license, please. That's TMI. CRLs are TMI. It slows things down. I just need to know the current status. Is this serial number, driver's license number, good or bad? And that's OCSP. Definitely better when it works. But we know what signatures do. Nothing new here. And you were going to see there's a lot of redundant stuff. So throughout the class, it's important. Hopefully it works as a reminder. We're not going to criticize it. A security architect is designing a system that requires secure key exchange over an untrusted network. Which cryptographic approach would be most appropriate? It's exactly the first purpose of it, right? The very first asymmetric algorithm is Diffie-Hellman, and that's its only purpose. It can't sign. It was later with RSA that we learned we could sign by keeping the keys long. Right? Hold on to that key. You don't hold on to a Diffie-Hellman key. An organization needs to ensure the integrity and non-repudiation of electronic documents. Which cryptographic solution should they implement? Hey, that's easy. And remember, a lot of it really is. If you come in there, you're going to nail a lot of baskets if you're just relaxed. It's hard. It's hard to be, just getting on stage. Just getting on stage as a musician is nervous. Just for what I do, public speaking for some people. So I think it's performance anxiety. A company is implementing a public key infrastructure. Which component is most critical for maintaining the trust model? If the CA is wrong, all bets are off. And you only got to make one wrong. Let me go to my certificate there. I hope you appreciate this take on it, Ross. In this list of trusted roots, which currently has 70, why 70? Are there only 70 in the world? No, there's a lot more. Microsoft decided this is their list. There's other lists. My Dropbox has a different list. My Firefox has a different list. They should be pretty much the same, but not exactly the same. Okay. It's kind of weird. For the most part, but you can import them. Maybe you have some data loss prevention system and you need to trust that. So you go to certificates and tasks and you import one. You better have admin access to do that, and if it's wrong, every certificate could be wrong because they'll just say that's my CA. And the entire trust of the entire internet now just broke on your machine. Any name could be matched and lied to. You could be lied to that you're going to whatever, Amazon, wherever. And there's 70 in here, right? 70 certificates. And if any one is wrong, they're all wrong. If this were a Bitcoin blockchain decentralized network, they would need to have 35, that's 50% plus one. So I'd need 36 of them. And they actually rehash something every 10 minutes. Right now, if I could get you to click on a cat video, and this cat is playing piano, so it's impossible to resist this. It's futile. I can have a script that it's going to ask you, do you want to run this as admin? You're not going to see the cat video if you don't click OK. All right, so I want to see it. Yeah, I got to see the cat video. I poisoned it, it's done. One cat video over. If it were Bitcoin, I would need 36 of them. Of course, Bitcoin has about 1 million miners. So I have to get 500,000 people to click on the cat video, and they recompute every 10 minutes. So that I got to get them to do this within 10 minutes. Bitcoin's not perfect. I can break that. But what's the likelihood that I could make that happen? So that's what makes that decentralized network so much better. And we have to fix this. That's what SolarWinds and so many other exploits have done. So that's why the CA is the most important part. It's the foundation of trust. And a cat video that is playing the piano. It is adorable. All right, understanding cryptographic attacks. I kind of already went here. If you just have a puzzle, you can put it back together again. You could sit there and with this ciphertext only, just the puzzle pieces, brute force it or find some pattern. I don't know. Maybe it was a bicycle lock. And instead of trying to go, is it 0000 through 9999? That's an entropy of 10 to the fourth, 10,000. I just noticed that when you get the first number right, the lock gets looser. Maybe I brought bolt cutters. That's some side channel. Anytime you're not brute forcing, you found some other way. That could be because of frequently used letters got encrypted the same way. Over and over again, the same word keeps getting encrypted the same way. Or I knew the picture on the box. I saw it. So I knew that the blue was going to be up top and green was on the bottom. Now, a little weirder is you ask, you take a piece of the puzzle and you get to ask somebody, what does this mean? If it were Pig Latin and you sniffed out apihe, you could ask Alice, what does apihe mean? It means happy. Is Abe Bob? Yes. And you might find that pattern. That's a lot easier, actually, than the known plain text. This is the hardest to do. This is a little easier. This is even easier. You know what's even easier and not written here? But it should be on the exam? Chosen plain text. Because there's a related question about it. The chosen plain text can be done two ways. I could do a big batch file, like they did in the Midway during World War II when they suspected a Japanese mole, and they sent out a giant message with the word water spread throughout the message, and then looked for that word and found it. But it would be even cooler, like with a puzzle piece or something, or if I said, hey, how would you encrypt the word test? And that's differential analysis. And I would encrypt that estte. Well, how would you encrypt the word vest? Estve. So best is estbe? Boom. So that's the most powerful type of attack. And that used to be quite common knowledge. And that's the purpose of the avalanche effect. If you use a tool right now, if you use a tool right now and you try to do a differential analysis, say on SHA 256, and you put in the word test and you get some 1 or 256-bit hash and you change vest, it's going to be like all the numbers are different. That's to mitigate the chosen plain text. It's common knowledge that mitigated with something that would allow like a small change to set off a huge avalanche. And this is supposed to be black. Yeah, with the avalanche effect. So if the attacker tries to do a little differential analysis on an SHA hash or any block cipher, that's not good. That's right. That's the purpose of that. All right, watch my time here. 5 more minutes to summarize this up, and then we'll come back and do questions. Move on to the next part. Again, most of the problems are the implementation attack. They're not storing the session keys properly. You salted something with an IV. It wasn't supposed to be used that way. One thing is to just make it fail in any system. That's not just with encryption. That's basically what a hacker does. And that could be looked at as like, hey, this ladder says it can only hold 200 pounds. Let's put 250 pounds on it, see what it does. And you just want to see does something fail in a funny way, in a useful way? Does it reveal something? When you get like a web error, it gives you usually like those 404 errors. They can give you some very meaningful information. Timing attacks. Early password systems used to reject you on the first wrong character. So you put in the password and it's whatever password 123, and you just go, is it A? Nope. Takes you 2 milliseconds, you're rejected. B, then 2 milliseconds. But if you put in the first letter, is it P? You get rejected, but it was 4 milliseconds. First letter P, PA, right? That's how you would get it. So they learn to parse the entire password. But if something's taking a long time, versus other things, we can guess, you can infer things. Man in the middle, it usually works especially in crypto, by spoofing public keys. Like the fact that Diffie-Hellman, if you tried to use that in all situations, it wouldn't work because you can't validate the public key. Nobody digitally signs. There's no CA that says this is definitely me. Perhaps the funniest of, if you ask the wrong question, the answers don't matter. Hey, the password's password 123, and Eve's got a Wireshark and she might sniff it. Let's encrypt that with a hash. We'll run that through SHA. And Eve sniffs out the username is Bob, and the password is this 160-bit hash. Hey, let me log in. What's your name? Bob. What's your password? I don't know. This hash value? Must be Bob. Encrypting passwords makes no difference. It doesn't help you one bit. If you always accept the same encrypted value, they'll just copy it and replay that. That's one of the most famous hacks that still happens today in any large network, because they couldn't turn off Windows LAN Manager. And Windows, the old stuff, their old NTLM stuff, is very vulnerable to local workstations, not the servers, but local workstations still have this stuff turned on where, think about it in a Windows domain. You're like kind of like a, let me finish 1 minute here. But when you're going into amusement park, and you as a person go in and out of the amusement park, you're not there all day. You get an all day pass and then you're not, you get a new one. But the server's not leaving, right? The domain controller is not leaving. They stay. They're like the rides in the amusement. They get a TGT, like it's an object ticket token, whatever, that doesn't expire. The domain controller gets, or you're getting a ticket grading ticket, they get a golden ticket. And the servers get a silver ticket. And if you couldn't turn those off because some server might break, people can copy those tickets. And the funny thing is, people reuse passwords. So now you got an admin who has local administrative rights to that machine. He needs it. They get the local admin password from that machine. And then I wonder what his domain admin password is. And then they own your domain. And it's all passing the hash. And that's what 312 is. It's one of the, if I get the domain controller, it's a golden ticket attack. If it's if I get it, and actually the countermeasure is kind of cool. They call it SMB signing, server message box signing. And what it does is it just signs it with your IP address. You can't use that golden ticket unless it comes from the IP address of a domain controller, and you have a limited number of domain controllers. How many servers do you have? Those silver tickets are really hard to lock down with SMB signing, because if people are constantly spinning them up for a microkernel development thing, every microkernel gets its IP address. So it's kind of tricky. We'll just watch for in the exam. It's just about time we know what ransomware is. So I think we can break for lunch. Let me pause the recording. When I gotta, let me say, clock. Here's my clock. All right, welcome back. Now we're ready. We went through all this important stuff here. So as we go through this, the brute force is if I have a bicycle, right? It's got 4 wheels on it, and there's 10 positions each wheel. Like instead of a bit with 2 positions each bit, whatever. That's the entropy of the system. There's 10,000 possible things. And the work factor is the processing time. How many bicycle lock combinations can you try in an hour? I think if there's 10,000 possible bicycle lock combinations, and I could try 1,000 an hour, after 5 hours, the odds are 50-50. I got it. If I'm running to the store for 15 minutes, it's probably good enough for that use. If I'm going to be all day working, it's not good enough. Except for Most bicycle locks don't give you that type of entropy. They are vulnerable to a side channel attack. If you get the first number loose, the bicycle lock will get looser. I mean, the first number right. So you don't have to do 1 in 10,000. You do 1 in 10 4 times. So there's a lot of different ways that entropy. The coolest way is with the hash. We now know when the opens like IETF standards, the first password protocol, the first Federation Standard Protocol over the internet was PAP, and it was clear text, and we said stop doing that. Then we went to CHAP, and CHAP eventually understood you encrypt it, you hash it, but you hash it with some other number. So like when you would log into a CHAP server with your dial-up thing, you give it a password, or actually you say, I'm Bob. No, it in clear text or whatever. But then the server would come up with some salt, a secret number to add to it. Let me think of a number. And it just comes up with a number. Hey, take this number, N value. I challenge you to put in your password and also run it through SHA, and that's OSA 75. I challenge you to do that. And you should come up with the same number. And if Eve sniffs it and tries to replay it, the server's like, nah, it's already been used. It's a new number. And she goes, well, my name's Bob. And he goes, here's a different number to salt your password with. And it doesn't work. Right. So that was the beauty of that. And we knew that over the internet. People don't always do that when they save passwords locally, especially when you just leave developers. Make up your own password system like they did at LinkedIn. And in LinkedIn, they didn't salt the passwords. And 2012 password hack. And so because of that, they were able to. A password's not like I say you can't reverse reverse a hash. No, you can't. Nobody's reversing a hash. I'm not taking a 160-bit SHA hash of a Linux distro that's really 4 gigs and recreating that Linux distro. But what I could do if I know that it's a password, and I go, I bet you they didn't make no passwords of more than like 8 characters. Create a list of every possible password, or just get the most possible, most common passwords of that year. You don't even have to make the full set, and just previously hash them and try to see if they salted the hash. Did they add anything, or did they just hash the password? And LinkedIn failed to do that, and that's why all this stuff hackers got encrypted text, and then they did every color of the password you could get, and that's why it's called a rainbow table. But a rainbow table is just a pre-computed hash value. So whatever, that's a side channel attack that still works in a lot of systems. Anytime you leave the developer up to things, that's why we want to use an open standard. We want open ID everywhere if we can. With MTLS that we learned in this class. Thank you, Ross, right? Stop calling you Paul. All right, ciphertext only. We talked about this. There's a lot of different ways. They're not going to work. Beat it up. We covered it. Fast as Kerberos. If you need me to stop, please let me know. But known plain text. I saw the picture on the box. It makes it a lot easier to put the puzzle back together, right? Frequency analysis, the header of any IPsec session is probably going to start with the same, I bet you the IP address, the last couple of digits are this, you could do, I don't know that anybody's actually really done that, but, sometimes people are going to always encrypt the same values, right? Chosen ciphertext is like when I can pull something out, and it's more powerful. This is how a lot of WPA2 hacks work. Is you sniff out traffic, right? So you sniff out just encrypted traffic, and then you start trying really with a password attacker. Is it this? Is it that? And then eventually you can find it. But the most powerful that's not in your thing. So I got 3 questions because the countermeasure is definitely testable. So it's kind of funny. They left it at the official text, but chosen plain text with differential analysis by far the most powerful. See how they encrypt this word. See how they encrypt that? Change one letter. But the most common really is it's not the algorithm's fault. So it's just what happened. Right? Anytime. There's just any way you're not brute forcing, it's a side channel. Don't get too caught down in the weeds. As a waiter, you only need to know that. They didn't brute force? Yeah, it's under side channel. A fault injection, we said it, sometimes error messages will trigger funny things and some timing, whatever. Man in the middle is because we get public keys that aren't authenticated. You need mutual authentication. You need something like not just TLS, but MTLS. Now, I also, if you're like Larry, but doesn't ETLS and ETTLS provide mutual authentication with TLS? But we know that provides it at layer 2. Probably too much access for today's zero trust networks that prefer to do it at the application layer, the transport layer. So I think MTLS is a lot more than zero trust. Pass the hash, replay, it's the same thing. If you look it up, it's that you encrypted the hash and I replayed the encrypted value, and everybody just, whatever. All right, there's okay, Kerber roasting. You said pretend to be the server. You can pretend to be the domain controller. It's kind of funny. Oh, there you go. All right, hold on. Maybe I could do it with just right from here. If I just look at whatever certificate information they gave me, I will. These two values. Certificate key usage. They're allowed to sign stuff to let them know that it came from Google. And that's all I, as a consumer, care. Are you sure? I get a non-repudiation, right? But there's some extended values. It can do TLS, so it can be used as an ID card. Sweet. There's actually like 40 different values you can check. Usually whatever you're applying for a license for, and even though the license format to be a truck driver, a pilot, whatever, all are different things. Oh, Arpita is calling. Hold on, is there something wrong? Arpita, is everything okay? Oh my gosh, I'm so sorry. Oh, there you are. I had something blocking it. I thought you were calling to let me know that the system was down. Oh, I'm so sorry. Well, that's better news than I thought. Hold on. What resumes transferring all the who I'm clicked on there. BMA co-host, yes. So there's like all these X.509 certificates to be any service or user. It's an X.5. It's your LDAP entry. Everything you can have in an Active Directory thing or role, whatever, can be in your certificate. And you could validate that you're allowed to be a server, that you're allowed to be whatever an EAP server, you're allowed to be an IPsec EAP server. But what if you clicked everything? I've been showing people how to do that. I won't say how to do it, but my students have been showing for years before Microsoft became vulnerable to this. And it's called the golden certificate attack. It's because Microsoft Active Directory certificate services. There's templated stuff, defaults, and when you just add a new user, there's just a template in the background that just passes something. Someone sniffs that thing out. It's part of a replay attack. Clicks everything. I'm allowed to be that I could drive a motorcycle, I could drive a car, I could fly a plane. Everything. I'm everything, and then they get everything. And then they pass it back. Oh, I guess he's allowed to do that. so there's a few ways to do that. Now, this is kind of like having a passport that says I'm God or whatever. Now, when you use a passport, it's for authentication. When you claim an identity, like when you log into the domain, going to get your TGT, or you go into the airport and they're going to use your passport to check you. You still got other security measures. Maybe they're doing, and I need to see your iris, you know. Once you get in the airport, they give you the TGT, the all-day pass. Now all you have is, in an airport, you got your boarding pass. That's an authorization. That's not authentication. I just say, I'm authorized to come in here. Nobody at the airplane store says, let me see your ID again. They did. So they figure that's been done. If I have a golden certificate, they still might check my ID. I still got to give my iris scan. When you log into the Windows domain, you get a TGT. When you get that federated, it's like OpenID or the old SAML, which is all XML. It's the like SOAP is to REST, SAML is to OpenID, or yeah, OpenID. So golden SAML attack, that would be worse. And that's what happened in SolarWinds and why I was jealous, because I had already thought of a golden certificate attack. I didn't even think of this would be even better. It just looks like you've already been through security. Oh, I can see you already went through the metal detector. Okay, fine. No, you're in there. That was way better, and I didn't think of it. Yeah, that was one of the, looks like there's still, this is newly discovered, whatever. There's been a few. So golden tickets, silver tickets, golden SAML. That's like the worst. All right, ransomware. I think you guys know what it is, and it's just it's a denial of service attack as opposed to our breaches. You know, but it very prevalent, and most people don't get their stuff back. All right. Attacker is systematically testing every possible key combination to break an encryption key. Which type of cryptanalytic attack is being used? Every possible combination. Yeah, he's trying to brute force it. And that's what when we say that, you know, after Moore's Law, and I've been using AES at 128-bit, and I believe the number was 2065, that my AI system to agree with, if Moore's Law, you know, so that's a brute force. But if we find no, AES itself has a tendency to pick B for the answer, then that would be a side channel or something. During an incident investigation, it's discovered that an attacker was able to recover encryption keys by monitoring the power consumption of a cryptographic device. What type of attack was this? Oh, I included it. Gosh darn it. Son of a gun. I'm so sorry. Messed that one up. No, it's a side channel. Yeah, it's like I cut the lock with bolt cutters. I don't care how strong the combination was. I added a fifth wheel. There's now 100,000 combinations. I bought bolt cutters and cut your chain on your lock. You know, that's side channel. Man, sorry. Yeah, anytime you're not brute forcing. So sometimes it's more precise. So we were talking about that, you know, they're both right. Suppose they said an attacker captured some ciphertext and was able to determine a pattern in the output and guess the value of the key. Well, that's a side channel. He didn't brute force it. But one of the answers was side channel, and the other answer was it was a chosen cipher attack, a ciphertext attack. Well, yeah. Yeah, that's under side channel attacks. We have chosen cipher, chosen play, right? Different. They're all side channel. So it's more precise. Larry drives a car. Larry drives a Honda CRV. Well, they're both right. Pick the Honda CRV. An attacker has gained access to several encrypted messages and their corresponding decrypted versions. Which attack method are they likely to employ? And none of these are right. I'm so sorry. If they think it's C, I have to tell you, I got kicked out of Claude yesterday. It maybe you're generating too many questions. You got to wait till midnight. I'm going to be asleep. So I went to Gemini for a little while, and I don't agree with this. It should have been chosen cipher. And I don't see, well, what does it think is the answer here? No, it's not known plain text. No, it's got it reversed. Anyway, we're not going to beat that up. Sorry. A malicious actor was injecting hardware errors into a smart card during cryptographic operations. Which attack type is being used? And yeah, we see that. Yeah, fault injection, classic. See an error and see how it responds. What will it do? Will it do something cool? Will the ladder explode? Generally there's just dead, right? You got to figure out how will it fail. And that's like the purpose of fail secure. Your testers have to make it fail. That's how they know that ladder can only hold 200 pounds because they tried 201 or whatever. And generally they give you, somebody like Larry at home might risk it and try to put his, 250-pound butt on there. I once weighed that much, whatever. So they'll give us some safe tolerance because the average idiot, yeah. And then make sure it fails secure, especially with like kids' toys. An attacker has compromised a network and is intercepting authentication requests between clients and servers. Which attack are they likely conducting? Hey, Hal.
The chat window is awfully quiet. Put your answers in the chat. Don't hesitate to get it wrong.
And
Jay, thank you
a
for
lot
the
of ways to do this too. Actually, they used to beat it up. I don't want to. Yeah, I see the answer there now. What happens is we mentioned in cryptography. So remember how Diffie-Hellman worked? Bob thinks of two numbers and Alice thinks of two numbers. And when Bob yells his number out, how does Alice really know that was Bob yelling out? I could just go out and say, "Hey, I'm Bob." He said his name was Bob. So Diffie-Hellman in that type doesn't know how to authenticate those public keys. That's why you don't do that when you do a digital signature. You'll get an RSA ID that lasts for like 4 years, and you keep a private key. You know what I mean? But if I don't validate that, or if that digital signature is wrong because SolarWinds lied, or got compromised, then Bob could get what he thinks is Alice's key. And it's really Eve. And Alice gets what she thinks is Bob's key. And it's really Eve. And Larry, isn't that a woman in the middle? Yeah, I don't think they should call it a person in the middle. But yeah, so now we have an eavesdropper. And it always happens because just like your old ATM memory card, you only proved who you were. You didn't ask what your smart card or your CAC. Prove to me you're really a valid DoD server or really my bank. And that's what smart cards can do. So that's the purpose of the smart card is you authenticate both ends. We do mutual authentication. And Ross, introduced us into MTLS, which can do that at Larry's biggest worry about security in general at the API level. I love it. That's been a great class just to learn MTLS. Hey, so I'm just going to skate through the rest of his. So does that make sense? Did that answer your question? Everybody understand why it's me in the middle? Well, let me know. It's a very a common problem. I can do it in NARP cache, and it's really hard. When we get into networking, the ARP is always constantly running because I'm not going to remember your MAC address. It could change. I just don't feel like learning it. I'm going to hold on to like 20 seconds, whatever. So I know you by your name. Then I get some IP address, and then I go, hey, who's got 10.1.1.1? And what do I always say? People don't authenticate cache. And you go, I do. And I go, hey, whatever. Apparently, this MAC address says it's him. Why would he lie? And people lie all the time. if I didn't ask you, what your name was, why would you tell me that? So whenever you didn't ask a question, but you get an answer, they're trying to poison your cache. And it's great to do a man-in-the-middle attack. You send ARP replies pretending to be some IP address, pick the default gateway, and you send that to workstations, and then you tell the workstation, the server, the default gateway, excuse me, that you're that workstation. And this is really hard to lock down. An IP4, that's not an easy thing to do. That is not easy to stop. In your exam, you're supposed to know about MAC address and NAC, network access controls. And I'm sure with software-defined networking, this is a lot easier to control than it was when I was doing operations. But I believe it when I see it that it works great. Yeah, man-in-the-middle very prevalent, and again, it's always because we didn't mutually authenticate. Bob needs to know it's Alice. Alice needs to know it's Bob.
Hey, Larry.
Yeah.
Because I was wondering, would it be helpful, like when somebody says a question like that, if they name that the client Bob and the server Alice, and it'd be more clear what's going on?
That's my pet peeve with a lot of test authors is that they feel they need to vary from that standard. I don't know why. Is red better for stop and green better for, should mid red go? I don't know. It works now. Why change that? Bob and Alice are working, and that's I think we should always be there. We know that Alice is a good person. She's a very dedicated employee. Bob might be stealing. We don't know, or he just might be sloppy in his work. Dangerous shortcuts. Eve is always eavesdropping. She's the passive attacker. Mallory is always doing active attacks. She does those synth ones and stuff like that. I stick with the standard. Unless you prove to me red light should mean technically they've proven it now with AI that it would have been better if we switched that to go. I'm sticking with the default. Security team discovers that attackers are exploiting delayed inputs in a system's response time to gather information about encryption operation. Which type of attack is this? Yeah, and I bet you could tell somebody the difference between whether they're using ECC or RSA just by which one took longer. Attackers have gained the ability to input specific messages into an encryption system and observe the results. Which attack method does this describe? The most powerful of them all. Yes. Get out of the way. I'll pick the word. How would you encrypt the word? Test. Este. Vest. Estve. Let me guess. Best is espe. Awesome. An organization discovers that attackers are reusing captured authentication hashes to gain unauthorized access. Which type of attack is this? Also known as a replay. Doesn't matter if you hashed or encrypted a password. If you always accept the same value, then they'll just replay that. You must accept it once. That's called a nonce. A number, this is how when they say it provides replay protection. What they mean is they probably salted, like in the case of a password, I give you this number, salt your password, send it to me real quick, and then they can't use that number, that salt again. So salting and numbers used once. And of course, the salt can't be predictable. So it has to be random or pseudo-random or whatever. Yeah. And that's all those silver ticket attacks are, and then Microsoft. So malicious actors have encrypted an organization's data and are demanding payment for decryption. Which type of attack is this? Larry, is there a bias toward A right here? Maybe, I don't know. An attacker is exploiting vulnerabilities in the Microsoft Kerberos implementation to forge authentication tickets. Which specific attack is this? Here we go. Yes, and which is a pass the hash but this precise one, so B is not wrong. Yeah, I would partially correct it. It's not as precise. Very good. All righty, we did it. At the start our network, which is much shorter than my old network. I hope that's for the better. Larry isn't going to go down in the weeds in his network.
Domain 4 is deceptive, Larry, because I mean it's very easy for you, but to me it was one of the harder domains, just because there were so few exam outline bullets, and it was so big in terms of material. So everything else seemed to be proportionate in size to the exam outline, except for networking for me. Not
Well,
sure if
so
anyone else feels that way.
said you came. We approached the stack and meet at the transport layer. I came up, yeah, this side. I can tell you more about cable. It's the same with my wife. It's, she actually likes to say she does everything better than me, but she'll nod two things to me: packet analysis and crypto. And I think now AI whispering. And she's getting good. She's getting good, but she still gives me the nod to the point where she just calls me the total. Uh, So yeah, 4-1 is huge, but the other four, where's it 4-3, 4? Yeah. So let me just, this is like, the overall what Larry knows, and please hold me down. But I think the bigger takeaways, and what I use Gemini to prepare for my exam for, by the way, because I didn't do this stuff. And so it was really cool. My intuition helped me a lot. So I was able to say, oh, and this too, the virtual private cloud. But software-defined networking. So when I was, and this is the way you configured routers. You first get the router and you take it out of the box and it doesn't have an IP address or anything. So you need to connect to it over an RS-232 port, an old layer 1 serial connector that your fax machine still uses to talk to the telephone company. If you have a fax machine, that's the same connection we did, only without requiring a phone number. So you connect this cable, and then you connect your machine to it, and then you set it up with an IP address and stuff, and then you could sit at your desk. Now it's in the data center, and you telnet it to it, but we know that's clear text, so we evolved into SSH. But either way, I got to talk to that device. And if I have at the trading firm like 50 routers that I need to propagate a route to, or an access control list entry, I needed the telnet to 50 routers. So now you're whatever AWS, and because a lot of people are buying whatever this sign up to Dropbox on one day, you need to expand bandwidth on all these routers. You don't have people typing. So you connect, instead of me or a person to it, you have a controller that talks to all these devices. These devices are passing data traffic from customers, and you're talking to them and they're talking to each other. And I don't feel like setting up separate cables. So I'm giving administrative commands on the same data channel, the physical connection. I'm going to logically separate it and encrypt at least. I don't know what the customer is doing. That's not my business. But in software-defined networking, that controller encrypts all that traffic to those devices. So now, if I, as an admin, say I need to open that up, I need to propagate these changes, I don't have to tell that to all those things or SSH. The controller propagates it everywhere, separating that control data from the data plane, so to speak, through encryption. But I've separated it and ensured that they can't get to that. If anybody noticed in my last couple of classes, by the way, the last couple of years, I've been discouraged how my trace routes don't work the way they used to. And ICMP is a funny protocol. It's not for applications. It's just for routers, basically, to talk to each other. So, but I needed to do my trace route and ping. And after 9/11, people started turning it off. And you're like, oh man, now I can't even troubleshoot that network. I'm not a hacker. I'm just trying to troubleshoot your problem. So people are like, yeah, what's the risk? And they weigh it out and they start out, and this one will let it. But now with software-defined networking, I'm finding big networks are just like, no, if someone's going to trace route or do any ICMP pings, it will be our people inside in our control plane. So I can't do that now. Those data planes won't let me do stuff I like to do. Yeah. So, but now I said I'm telnetting to it, but that's not the end of it with software-defined networking. No, it's not a person; it's an application that says the Dropbox application says I'm getting a lot of demand today, or probably ChatGPT. I get the message all the time, right? So that Azure, that ChatGPT's APIs are saying, hey, I need you to open up that bandwidth. All right. So the communication between the controller and the app and ChatGPT is northbound traffic because you're always taking it from the perspective of a controller, whether it's GDPR or software-defined networking, where security people supposed to control stuff, focus on the controller in SDN. Northbound, you're talking to the apps, you're servicing your customers. Southbound, you're talking to the devices with your control traffic separated from the data through encryption. But what about when servers or other controllers are talking to each other? That's east-west. In a microservice environment, that's driving a lot of the traffic. So those APIs in a lot of microservices are actually considered going east and west as well. So that was new stuff for me. I had to get my head around, but everything else here. And this is always the answer somewhere in your incident response for containment measures. So you're going to use your software-defined networking to just isolate maybe that API. You didn't break down everything. It's not like I had to, evacuate the building because there was something going on, burning popcorn in the kitchen. I just isolate the kitchen. But we're going to look at the OSI model and get some basic fundamentals that'll help you answer a lot of basic questions. Not that they really beat up the OSI model, but that you get an understanding of context. So the OSI model was just a more granular look at the TCP/IP model. When I first learned it, I was told it was going to replace TCP/IP because it was good. TCP/IP is going away. Well, it didn't die. When a person uses a computer and they use their application, their email client to write an email, they're creating data. When they send it to the mail server, they got to know the port number and the IP address of that machine. There's other stuff in the segment and packet header. There's other, just like on an envelope, I don't just say to Larry or whatever. I got to say at this, whatever, zip code. I always imagine that me as a packet analysis, really, I have the skills of a mail clerk in the 1800s. I'm basically the same guy. I know how to read not just to Bob from Alice, but I can tell you the zip code. You guys know what zip codes are? That's how dumb you are. You don't even know what a zip code. That's what I'd be like, It's not really that hard. This is 20 bytes of information. That's 20 bytes of information. How hard is that? These application layer guys who are much smarter than me, that's millions of lines of code. This is where my specialty is. I told you, Arpita and I meet down here. Somewhere I came up here. So in TCP/IP, your data gets encapsulated in a segment and in a packet header, and this creates a circuit over the internet. That's what circuit level firewalls do. So that's what circuit level gateways do. When I just know, hey, you got to go to 10.1.1 to port 80, that's called a socket. This is what a SOCKS-based firewall does. A SOCKS proxy, however they word it. There's a lot of, well, I won't go down the way, but there's a lot of cool proxy man-in-the-middle attacks too that can proxy. Once they know the man-in-the-middle, they can proxy the web server itself, Burp Suite and stuff like that. But who plays with those tools? And there's other information in here, like in TCP, as opposed to UDP, there is state information. This is the beginning of the conversation. It's like when you start a phone call. It's a SYN. Hello? SYNAC. Hey, Larry, it's Bob. Hack. UDP is just like this speaker at whatever the grocery store. And I'll tell you there's a yada, yada, yada. And I'm like, okay, whatever. Is that for me? Whatever, you know? So that stateful stuff is how most applications still work today. I argue they need to go away. TCP needs to go away for most apps, and because I got Ross and some other cutting edge, I'd say people in here, I'll touch on it real quick. Arpita, I promise I won't go too far.
You're
But
fine.
it's quick. It's just quick. I just love quick. All right, I'll plant the seed real quick because I think it's right in this trace, and then I won't do anything more unless it's a break. In a TLS, let's just follow this handshake. In fact, here we go. I'll make it applicable to our conversation right now. Talk about TCP and the three-way handshake. Perfect. Right, do I have there's the SYN. In order to set up a TLS conversation today, think most people, you can't use UDP. You got to use TCP. And the very first thing before I can even do the client hello, the encryption stuff, the TLS stuff, I have to first do the three-way handshake. If I did a client hello over UDP, couldn't I make it like still stateful? Because there is a handshake now. I'm not just talking, hey, everybody. I'm going, hey, let me see your certificate first. Do I need really to do a SYN-SYNAC? Wouldn't it be quicker at this point to just trust that? Get rid of the three-way handshake. That alone makes it quicker. But there are so many other improvements that are way out of scope. And I'd be very glad to talk about, especially if anybody does blockchain development, because I keep checking away AIs, and I'm the only one who's pushing this that I know. All right, but anyway, Larry, please, testable. All right, so when you write data, you put it in there. Now, when the mailman picks up your envelope and your destination IP address is in another country, he's not picking it up and dropping it off at that other country. He has a special, and I'm just going to look at your address from a different perspective and drop it off at the mail hub, okay? And I'm going to let him know about this, and then he's going to handle it. When you encrypt like WPA at your router or your access point, and anytime you implement this frame, what this is just your physical address that came with your network access card, your NIC, your network interface card, and it has certain whatever radio waves that it will listen to, and it goes, hey, this is for you, and yada yada yada. The router takes that frame off and builds another one. It's like taking the mail from a truck and I'm going to put it on an airplane. I don't need truck license plates now. I need airplane frame headers. So that's what happens. As you change media from an airplane to a Wi-Fi to an Ethernet to whatever, you're changing frame headers. That means that these MAC addresses are only locally significant. And that's what's in the frame. So again, port number, the app, the operating system IP address, which might be on a machine that's like, the IP address for my virtual box. Each one of them has a different IP address. They're all going through the same MAC, right? So this just tells you the packet, the network address is all that they really care. And then I just got to make sure the local mailman is set up. With the devices that we always think of, the layer 2 switch, the bridge, just rebuilds, the frame, or excuse me, reads frame headers. Oh, I know this MAC address. I learned them. You plugged them into slot 345. But the router, it looks at the IP address. The routers also look at port numbers. And in TCP/IP, the Internet Engineering Task Force, routers are not defined at layer 3. They are defined between the host, and the internet layer. And I'm probably telling you too much information. It's an old question that people got rid of, and I agreed with it. But since it's not there, moving on. They might, I don't know, it works at the network layer. Transport layer, though, this is really, routers can make decisions based on that. And when I use transport layer security, what I'm telling the application is, hey, I'm going to encrypt all this stuff before, whatever you got clear text up here, before I send it out on the internet. I'm going to encrypt it right here. That's what TLS does. IPsec doesn't care what application. Everything behind that IP address. And when you're using WPA2 to your router, actually, they don't even care about the packet header. They can encrypt everything. Of course, if you're going to go through a router needs to see that. That's why it's always decrypted in every router. We also have firewalls that can inspect traffic at these different layers. Right? So our first firewalls really just check to see, is the IP port number really of our web server? Because if it's not, let's not even do that. Let's not let you in. You're only allowed to see our web server. If it's not going for whatever 205.6.9, that's not port 80, well, then you're not allowed in here. But just because you say, oh, it's port 80, that doesn't mean this is good. One thing, you could run any protocol and lie about the port number. So there are, in front of any data, not necessarily the data itself, that's deep packet inspection, but just a little further in, if this was port 80, then I should notice at least an SMTP header, or excuse me, a HTTP header. So application layer firewalls don't inspect data. They're not your application layer mail firewall is not reading the mail. It's looking at the protocol header and making sure that that one really is mail, and two, that it's a valid mail command that you allow. But today, everybody's trying to encrypt this stuff, so that doesn't necessarily work. And now is when we do our like DLP systems that actually decrypt stuff, doing a man in the middle locally. But some way, I have to, in my work, assume that all this is encrypted. When I do sniffing analysis, this is typically all I get anyway. But you can make some good inference. And I could show you, actually, that's part of our crypto thing, is how we can, if I'm local and if I'm locally on my machine and I have whatever Firefox loaded and I go to the ISC2, my machine generates that TLS handshake and they give me their certificate. I come up with some value. This is going to be used to generate that session key in that elliptical curve Diffie-Hellman. And it's going to be whatever they call it, a master key. We'll just call it a master key. This is what they're going to salt, some hash, and then come up with this an encryption key. It happens the same way in WPA2, by the way, a master key. And I'm going to take this value and I'm going to encrypt it with their public key. Right? So they gave me their public key. I create this number. I encrypt it with their public key and send it back. And that's why no hacker can see it, because they need their private. Well, if you're doing troubleshooting and I need to see this data and I turn on Wireshark from someone else, I'm an outsider. It's only from this Firefox browser. Firefox and Chrome, I think Edge still doesn't allow it, but I can ask the application, hey, would you write that down and leave it in the room so when the cleaning staff come in later, they can check it out? So I can keylog that file and just that one session key. And you can troubleshoot and look at data, but that's a very rare specific. You know, when you're troubleshooting with Wireshark, I like to say it's like watching a football game with a 30,000 power telescope. That's when you want to make out, you know, that thing on the quarterback's nose, but you might not know the score of the game. So it might be way too deep at something. Yeah. All right, go back here. But it's very useful. I'll tell you what, you can only speak matter of factually about what you measure. And I like to measure those packets and go, yeah, I know you think you got no IPv6 in here, but I'm telling you 30% of what I saw today was IPv6. So, all right. IPv4, and speaking of the devil, and IPv6, IPv4 is a 32-bit address. You can guesstimate any address for every 10. So every 10 bits of entropy, by the way, it would give me about 1,000 things. So if it were keys or whatever, in this case, addresses. With 20 bits, I get about 1,000,000. With 30, I get about 1,000,000,000. And then you just double the two, double about 4 billion addresses. And we have way more, we have 8 billion people, and we got billions of agents. So we long ran out. That's why I find that myth of now we're all IPv4 here. Go, okay, so you guys aren't monitoring and managing your IPv6 traffic. Cool. The different ways that things can talk in IPv4 and IPv6. This is what actually UDP can do both. UDP can unicast or multicast or something. TCP is only unicast traffic. This IP talks to that IP. When you do a SYN and a SYN-ACK, that's between two IPs. UDP can like, hey, everybody who's like interested. Yeah. So that's a one to everybody. Like the ARP request is always a broadcast, right? They got rid of that. ARP is you can't turn it off in IPv4. It's very vulnerable. It's always clear text. It's very common. It's very easy to do a bunch of stuff with it. So in IPv6, they turned it off and they have something called an Anycast. But I actually asked a great security instructor, Rolf from Germany, but I said, what if I Anycast any? Isn't that kind of a broadcast? And I forget that he was like, it is. But I got a feeling that I just messed with his head, and he probably later on realized, no, you would just do this. So, but anyway, the Anycast is pretty cool in that you could have like multiple servers sharing that same um, um, uh, IP address. So that's pretty cool for load balancing. All right, so we went over TLS and IPsec. Remember, IPsec is a network layer. Typically, it's used for either remote site to site, and if you have like an infrastructure as a service connection to Azure, very likely that's how it's connected. I think that's the only way to connect it. So IPsec is very, very useful. That site to site thing. You could, and it's very popular for like remote access if you want to get that layer 2 access, instead of like OpenID or SAML. But a layer 2 access I could do with IPsec, and from the hotel be VPN'd into the network. And in theory, I could just have two machines in transport, just like I just want these two machines to talk to each other. And apparently the NSA was paranoid about that and deliberately broke it. I don't know that anybody's ever made a transport mode VPN work in the real world. I don't know how deep we'll get into it, but IPsec tunnels are very, very popular. The other thing is IPsec was supposed to be able to authenticate. Like, there's two things going on in the packet, right? I want to just make sure that, and it's mutual too. So this is a great feature. Is this really the source, and is that really the destination? Because it's not going to get routed properly if they don't have the right IP address. You can't lie about your IP address and expect to get traffic back. So that's got to be real. And so that's pretty cool. That's like saying, is it really the Chicago office talking to whatever the Philly office? And that's very cool. They would authenticate the header. This is the IP header. Problem is, when you NAT a 192.168 address, that's not going to look authentic anymore because it's not going to get to them as 192.168. So authentication header mode doesn't work exactly well. But if I embed this in the packet somehow, I can actually get ESP mode, what's only supposed to do the payload, to still give me mutual IP addresses. That's the short of it. I'm just going to tell you because I have some techie people. Let me show you a couple of things about the limits of AH mode, though, and the benefits of it. DSCP values, this is your quality of service. If you claimed you were DSCP 48, you're a router, you get top priority on the internet. We got to give them, it's a routing protocol. How do I know it's really that? Anybody can lie about that. Only AH mode could fix that, and we don't do it right. So that's pretty, I'll see. The version should never change. The total length, this absolutely it could, actually, no, it should not change from 1 to 1 unless it gets fragmented. So this might change. Time to live, oh, excuse me, the ID field should not change. That's pretty cool. The time to live changes at every router hop. You can't hash that. You can't authenticate that. Protocol shouldn't change. And the checksum is going to get recalculated every time the TTL gets changed. So you can't really check everything with authentication header mode. But I wish we sure could do this one because it's really easy to lie about who you are and steal the bandwidth. And we know that WPA, WPA2, WPA3, these are layer 2 things that just protect you to your access point, far improved over WEP. We'd never use WEP. But there's a problem. Even WPA itself, let me kind of skip ahead here. What's this week? Yeah, oh, I'm sorry. We just to clarify, and I have debates about this, but MPLS is a kind of a ability to set up like VLANs over like fiber mesh networks and stuff in our large networks, and it allows us to do controlling broadcast domains and stuff like VLANs do. I don't want to go too far into the hacking with that. Yeah, he's convert. They might go into this for some of the high speed, high performance computing. So this Compute Express link for CPU to CPU, this to me is like part of that whole decentralized physical area network that I think is coming. I think it's the future. So I'm very excited for this type of stuff. Oh, voice over IP used to always get beat up. Oh. There are 2 issues that we want to be concerned with. Who am I talking to? Is he really who they say they are? And 2, are they eavesdropping? Is somebody eavesdropping? So we're worried about authentication, stuff like that. Well, to set up the session, we have the session initiation protocol. It runs over TCP. And it's clear text. And anybody could lie about who they are. So we mitigate. Since it's TCP, we can do it with SIP TLS. I need to see a certificate, Next.509 certificate. Prove to me that you're not spoofing. Eavesdropping. This runs over the real-time protocol. This is UDP, which unless you're doing quick, and they're not, because, again, Google's been doing quick for 12 years. I know it works fine. YouTube has been running over quick for 12 years, but people just seem to look the other way. I don't know. Yeah, it's UDP, so people think you can't do TLS over it. So the way to mitigate it, I lost my control box here, is to mitigate with SRTP. Anytime S is at the end of a protocol, you need PKI certificates. If the S is in front of the protocol, you're cool. It's probably some version of SSH. But you watch out for those S's at the bottom. So do know that there's like now 6 testable objectives right here Do know that SIP sets up and sets up the session, including the caller ID. That caller ID in clear text and modified, not checked, could be spoofed. So we require SIP TLS to ensure they have a federated ID card. That's what PKI is. S says you need a federated ID. Now I know it really is Bob. But to make sure that the data itself isn't sniffed out and replayed, which is run over RTP, two different things, because it's faster. UDP is much faster. So we mitigate that with encryption using SRTP. Then we talked about the different topologies, and actually we didn't really go into when I was a kid. You started out. Actually, there were two ways to do a network. There was a ring and there was a bus. Ethernet was you had a big long cable, and then you would cut the cable. It's like, hey, we're adding a workstation. You go in there and you cut that cable and you put in a T connector, and then you connect a workstation to it over coax. It was just brutal. I got to do one thick net where you actually tapped into it, where the screwdriver that eventually, pushed in this screw, and so high tech and precision. Yeah. But then we got the hub. The hub changed everything because one wire just broke down everything. The ring was out there too, and if the ring broke, everything went down, potentially. So the star is really how we do all of our workstations today. Everything's done in the star today. I don't know that anybody does bus, but mesh and ring, like sonnets are still ring, so it's not in the local area network do I see a ring, but and a mesh, any in the high availability system, probably all, it's high speed fiber mesh. The data plane I mentioned, when you're in a say a cloud provider environment, all your customers' data is running through your infrastructure that you need to take care of. You need to administer that, and you don't want that administration traffic commingling with them, and you don't want to set up a different physical channel. So you encrypt over TLS your control traffic, and that's considered separation of the control plane and the data plane. I find this kind of bizarre that I'm supposed to cover this, but when something goes through a switch and reads a MAC address, just I got my wires real quick. This is kind of little trivia. Could get you on that episode of Jeopardy. In a segment header, what field comes first? Source, then destination. In an IP header, what field comes first? Source, then destination. In a frame header, what address comes first? Destination. Because they were slow. And I didn't want the switch to store the entire 1,500 byte frame before you measure. Would you just read the MAC address and send it? But they were sending errors. At the end of a frame is a frame check sequence. I have my OSI model handy. That's the only layer that has a trailer. Here's a little checksum to make sure it came out good. When they were doing this cut through, they were taking a dangerous shortcut in CISSP terms. Now, I think the date my AI told me was like by 2007, because I think Megumi Takishita is the one who laughed at me. No, I'm sorry, Larry-san, but every major switch today all stored in forward. They're all stored forward. And that helps you mitigate whether it's a malicious attack or just a checksum error. So that's good. I just thought that was a bit deep that I had to go to. But that's in the content outline. There we stop. Oh,
So Larry, only store and forward is used today?
yeah, it's all stored forward.
Okay.
I could have gotten deeper, you know. If there's a Cisco guy biting his tongue, what about fragment free, Larry? I know about that. I'm trying not to. Cisco found it than cut through, but it wasn't as because most of our problems were collisions. So they said we got rid of all the collisions. Anyway, the topologies again, the cut through before versus store and forward. Yeah, higher latency, but they all do that today, and it's a lot better. Understanding the difference between bandwidth and latency, I like to use in plumbing. So if I have a really fat pipe, I can get more bandwidth through there, you know, and I can get more water pushed out. When I turn on the faucet, how long did it take the water to come out? That's latency. And it's common knowledge that in streaming media, latency is extremely important, and you have to watch for these things. So if the jitter happens, you might have to work with those numbers and say, hey, don't cache so much. Don't do so much, say, store and forward. Stream it now. That's what happens. Signal to noise ratio. Well, any musician doing recording knows there is always noise. There's no such thing as quiet. Whatever room you think is quiet. So when I'm playing guitar, what's the difference between the ambient noise level and wherever I am and how much guitar music is reaching your ear? That's how we measure our Wi-Fi too, right? Signal noise ratio. All right, this is our software-defined network traffic flows, and I got a number of questions on this too. Suspected spam caller. No, then why don't we you message me? Anyway, so again, I got quite a bit on this, and this is where my LLM based exam, I thank you, Gemini, did such a great job. So again, watch out. If you're talking to the application, that's the northbound traffic. Server to server, controller to controller, APIs to APIs, you know, and anything, that's going east and west, right? Southbound traffic is when the controller is pushing those changes out to the device. Hey, the application says he needs more bandwidth over you in Chicago. You open up those routers now, you hear? So that's the southbound. Shift toward more east-west traffic at modern data centers led to forgot. I had to look up the spine leaf, and I already forgot what it was. I'm not gonna go there. But the microsegmentation is huge because the east-west traffic is where those APIs are, and if you suspect, even if it's not, you know, that kernel's fault, it got infected, you want to isolate that kernel. Still, if you want to trust that no one's getting in there, when they write crypto algorithms, there's no reason to be connected to anything. I want to make sure that I have a completely clean room, you know, it's totally isolated, you know. But when we do modern stuff and I'm administering stuff, I don't really feel like setting up separate cables. So we do some logical separation, you know. Air gap networks are when you're totally isolated. No, we're not connected to anything. I would hope nuclear bombs, for instance, but I know that that's how they develop crypto algorithms as well. Logical segmentation and VLANs are like layer 2 stuff that makes it look like you're plugged into a different switch, right? And VPNs are now looked at two ways. When I was a boy, VPN was using IPsec to take the public network, the internet, make it virtually private so I could remote access in from home. That's what I set up a ton of those VPNs. I set up a few site-to-sites. But then all of a sudden you get your NordVPN that's a little bit different. That's from me worried about somebody, a man in the middle, watching that I'm doing this here and my ISP, my own provider might be doing. But some of the funnest stuff you could do is just go to Google News from different countries and see what stories hop up. That's actually one of my favorite uses of NordVPN. What did they think I would be interested in if I were in Denmark? Virtual routing and forwarding. Now we have actually the way they're using it here is I can have one like I'm doing right now. If I have multiple guest machines, guest OSs that all have different IP addresses and stuff, I'm actually routing all their traffic through my interface to my ISP. So you can do what we call sub interfaces, I think is what they're saying here. That on this one interface, I can create multiple IP addresses and stuff. But without encryption, I don't trust that it's really isolated. And a lot of times you'll see terms on an exam that can get you tunneled traffic. Did you tell me what type of tunnel that was? Did you say an IPsec tunnel? Because if you just said like a GRE tunnel, that's not encrypted. Do not confuse tunneled with encrypted unless you know that protocol provides encryption. Virtual domains, and again, if you're a cloud provider, for instance, and you've got to handle all kinds of stuff now. We went over the software-defined networking, and I'm really looking for virtual cloud because that was a newer one for me. Did I skip over it? Might be on another slide. I apologize, but there's virtual public clouds, the private clouds that was kind of new for me, and it handles that multi-tenancy configuration of Coca-Cola and Pepsi being on the same thing. All right, so let me move on here. Again, with encryption or just a VLAN technology. VLANs are not necessarily encrypted. Oh, there's a newer version of VLANs. Oh, shoot. And I hope I see it when I see it. That is now. Because VLANs are limited to the number of VLANs, the old technology that I played with. But now there's a new VLAN. Oh, I hope I see it in the garage, because I think it was on my exam. No, you shouldn't be saying that. You should act like you know everything. All this stuff is done through software-defined networking. Now, our network intrusion detection versus prevention. That's a camera just picking stuff up. Prevention systems, that's what a firewall is. But they didn't call them IPSs. But isn't that what a firewall does? Yeah, but they don't call it that on the menu. Let me explain. Now, please don't explain. I don't understand how the nomenclature got about, but really what an IPS is, in my experience, a response to a Gartner ad that made something about in 2005. IDSs are a waste of time. They don't do anything. So your firewall can stop certain things, right? And it either says either you're allowed in or you can't. But let's say it allows it in. And the IDS goes, wait a minute, you're acting funny. How come you keep sending this SYN to the same server? Looks like you're changing your source IP address. That ain't right. That's it. Kick them out of here. This is a bouncer once you got in, So it is a preventive control. But there's another issue about it. Pretty cool. 2:44. Oh, we have, what time? We have 2:30. We need a break, don't we? All right, let me just show one thing. I won't take a break. I don't want to leave you hanging because it is very important to me in understanding how they work. And it could very much, if they still ask, I didn't see any of what layer does this work at question, but it could have been just me, whatever. A firewall, especially a stateful inspection firewall, which used to be a question, how does this work? And at what layer does it work at? And since Checkpoint coined and trademarked the term, I'm taking their definition. Why we receive a packet at layer 3, because we know this gets changed at every hop, right? The firewall intercepts that packet. You just give me that, you'll talk to my IP address, right? So you talk to the firewall's IP address. That's what they're advertising on the outside. Right? The firewall then decides whether or not, is the IP address right? Is the port numbers correct? Anything looking fishy here? And in stateful inspection, if it's TCP, you send a SYN, right? And they're listening on that port, and he says SYN ACK, and he listens at that. Okay, you SYN ACK, I should be expecting an ACK, and he looks at the state. So if he goes FIN, he goes, no, you're not allowed it. Because it's stateful. DNS isn't state. DNS requests generally run over UDP. So Checkpoint knew that, and they go, well, you can't look for the state information here. You can't. You're going to have to check the DNS header, and TCP/IP. We call that the application. So Checkpoint says we receive a packet at layer 3, we process it up to the application layer, and then if it's good, we will transmit it back on layer 3. And I go, why? Why do I need an IP address here? Why can't my firewall just be invisible? Why can't he just take the packet at layer 2? He doesn't have an IP address. Nobody even knows he's there. He's just a guard looking passively going, you look funny. And I wasn't the only guy asking. The reason they have an IP address is because it's not just a firewall. It's a network address translation device. It's a router. It's a VPN access point. It's whatever. It's a floor wax. So firewalls are generally were multifunction devices and built that thing. And IPS is a dedicated miter saw that is not also a spork. It just does what it does. And so IPSs receive things at layer 2. The only IP address that matters is the one you manage it from. It doesn't make any traffic decisions based on it. It has at least 2 interfaces, probably an out-of-band interface with an IP address to manage. But these are the traffic forwarding ones. And then they can now look at everything and no one knows they're there. So that's another great advantage of an IPS over a traditional firewall. All right, now it is just about 10 of we've really going on long. Let me pause the recording.
Thoughts or your opinion?
Sorry, I just thought it might be a valid question for the recording. Thank you, Kim. I'm sorry. Go back.
Oh, okay, it's fine. What I wanted to ask you about is that, like, oftentimes I've been involved in designing architectures for different infrastructures, and the question comes up of whether or not you put an IPS and IDS in front of the firewall or whether the load balancer goes first. And I just wanted to, out of those or those 4 things, how would you arrange them for entry into a network? You know, when you consider the IPS, the IDS, the load balancer, and the firewalls, which order would you put those in?
Wow. All right. So it's a great question. Let me try and draw something out here. So we know, first of all, whether it's combined or a hybrid device, and I would hope that probably where you're working, it's a dedicated thing is to first start with a router, right? Router's got to come first.
Yeah.
That'll get you on that network address. I should have made that as long as it is, but whatever. Well, so firewall versus IPS versus IDS. Is that where we're at now?
And the load balancer.
And the load balancer. That's going to throw me off. Let me take away the load balancer for a second, and I would do the simpler ones first. So I then go firewall, and I would think there's a lot of noise that I've just eliminated. That way, if I put an IDS over here, why would I want to do that and get all this noise and when the firewall already stopped it? This is the meaningful traffic for me. Now, depending on your risk assessment, you might need to see that. So I've had people say, no, we do an IDS, we don't log it long here. This is our longer term log. But if I only pick one, I'd go router, firewall, IDS and or IPS. Now, an IDS just needs a single interface and can tap into there. Can't make any change. You can't stop anything. Is that good enough for you? I don't know. Maybe this is a hybrid device today. Maybe this is a hybrid device in IPS. The problem with IPS versus IDS is, in my experience in the rule set, is your IDS wants to record stuff that it doesn't want to necessarily stop. So the rules for how many things you'll keep a record of usually really big. I'll have a lot of different rules for my IDS. But my IPS is probably like, nah, I'm only going to want to take action on these many. So usually far fewer. So does anybody here have experience on modern hybrid devices that can tell us that we can support both on our same device? And I would assume they do.
Yeah, you can. I know that. Yes,
Yeah,
you can.
that's my assumption through, especially with software-defined networking. You just
It's
do
all
it.
built in the firewall
Yes.
configuration now.
So I would say you'd go router, firewall, combination hybrid IDS IPS. Now, the question of the load balancer. I'm going to go to my AI assistant for that, if you don't mind.
Load balancer is going to be in the DMZ.
Hey, in the network architecture, and I need to place in after my firewall or before my firewall, a load balancer. I have firewalls, IPS, and a load balancer. In what order, coming from the outside network to the inside, is the most logical approach?
For logical network architecture, you typically place the load balancer after the firewall and before any internal systems. This way, the firewall handles initial security and the load balancer distributes.
She's gonna get too long. And as far as the IPS versus the traditional firewall, my guess would be that I would have the firewall first, then an IPS, and then you're saying the load balancer?
Yes, exactly, Captain Larry. Typically, you place the firewall at.
There you go. That's what my assistant tells me. She could have hallucinated the whole thing. Do not write that down on a government contract and say Larry said so.
I mean, that's pretty much the order that I would go also. It just sometimes we have people on the team who want to put the load balance out in front of the firewall, and I'm like, that doesn't make sense to me, because if you got that, I mean, especially when you think about the IPS and IDS, because like if you're talking about intrusion detection and prevention, I look at like a house, right? If your door is the firewall, why would you put your IPS after the door? Because they're already in your system. I would think you want to put your IPS on your porch or, in front of your front door. And so that's why.
Yeah, it would be really
They're
this.
probably talking about DMZ.
Well, we'll get to that even with, without a DMZ to let me
Because
walk.
it load balances the data and before it hits the second firewall. That's why.
Yeah, well, there's another firewall. That's another point. But I think just in terms of this very simple design, let's say we're talking about entry to a DMZ, right? So this is a DMZ network. I think that the firewall the firewall definitely you configure and say, I definitely don't want this. So don't even bother me. Don't even stop and ask me if I'm interested if it comes from these IP addresses. But if it meets that, come on in. Now, once it's in, it might start acting funny. And that's for why I prefer the IPS later. I didn't want to stop you. At first, you could have been valid. You seemed to meet you looked valid. And that way, my IPS doesn't have to do as much work. If I put that front, why don't you just get rid of the firewall? And many people probably can. There are probably hybrid devices that are saying we're doing that, And
No, I'm sorry there. What I meant to say was people want to put the load balance on the porch. I think the load balance should be after the front door. I'm sorry. I said it wrong.
load balance, and I didn't even think about it, but now that you bring it up, it makes absolutely no sense. Why would you load balance that get people? You go in line A and you go in line B and find out, oh, you're not even in the right building.
Yeah.
You're not in the right building. I don't need to send you in the two lines. Yeah, I'm sorry. You're absolutely right. That's a good point.
Yeah, I mean, I agree with you 100%. But oftentimes I'll get someone on my team who wants to put the load balance out front. I'm like, that makes no sense. But I'm a network, this, and that. I'm like, still, that doesn't make sense, because if you, like you just said, if you're in the wrong building, what difference does it make if I balance the load?
Exactly. Still, I'm always careful about it when something doesn't make sense to me, but that's just because I'm not smart enough. And because I'm married to a very smart woman who often says, "God, it just happens." I just have to go, oh, well, I'm good at lifting heavy stuff. You got to admit that. I'm better at that than you are. I can too. She can't lift much of it all, man. In fact, when we were moving, I moved better when she wasn't helping. Honey, if you really want to help me move the couch, would you just get out of my way? All right. We covered it. Let's get back to where we were. All right, so a couple of very important things in here. We've got to know where people come in and come out, and also know certain filters that are important when things come in. If you're coming into my network, you shouldn't have a network address of my network. So there are certain filters that you just go, that's just wrong. I don't have to do deep packet inspection. And we watch what can leave, a great way to mitigate being part of a botnet without realizing it. Don't let anybody leave your network whose source IP is not from your network. Now, when we appearing, when you have like our external services and stuff without going through, our peer-to-peer network, it's mostly going away unless it's the ISP networks. Most people are using the public internet to connect. What we used to have dedicated lines for out off the, by default. Your security, a lot of government places still want no dedicated lines, and if your needs say that, that's fine. What's very important in the newer material, though, is these content delivery networks and these big gobs of cache data they allow. So they're vulnerable to all types of caching attacks, cache poisoning attacks, maybe reading private data from these things. So they actually use like between, say, you watch a Netflix thing and it goes on that caching controller. If other people can get to that data, it doesn't mean they have the, and see it through. It doesn't mean they have the sign in to allow them a login to see it. So it's encrypted. It's encrypted over TLS and stuff. We talked a bit about the edge and making sure, like those caching controllers are pushed to the edge. Here's one of my big things as a router guy, though. Routers tell each other the best way to get from here to there. If there's a new street, there's a new network, up on the network, they got to tell, hey, I know how to get there. Hey, how do you log out? I can get there too, but my way's better. All right, we'll go your way. So they speak these routing protocols. And inside, we've had things like RIP, the router information protocol. And the best way is to pick whatever way took the least amount of routing hops. But you would take really, one hop over a 56K line instead of 3 hops over a 10 gig pipe. Yeah, that was stupid. So we took into account like OSPF, taking the shortest path. But BGP is what the routers on the internet speak. That's how I know not to get from 10.1.1 to 10.1.2. How do I get basically from Cisco's network to Microsoft's network, this autonomous system to that system, this domain, whatever. And it's an old protocol. It's kind of long in the tooth. It originally just used an MD5 hash password. It's hard to update these things. There are countermeasures out there, but still there's been quite a bit. Let's see what the status is real quick. I don't want to get stuck in the weeds. BGP hacking and yeah, public incidents, any incidents, hijacking, whatever. Yeah, because that's the best attack. You could do a denial of service, but why not make all traffic go through your network? Let's just see in the last year. Cloudflare. So it's a real devastating attack potentially. I know the best way to get to Bank of America through our domain. And they still get there. It's a great man in the middle attack. You remember when you're denial of service, if you get a ransomware attack, you notice, but someone's doing an advanced persistent threat and they're just siphoning data out. Everything still works. Our wireless networks, we know that there's just like any LAN protocol. Think about it. They're not just, local. It doesn't tell me what to do with the data link layer. It tells me what to do with the physical layer. All LAN protocols do that. So Wi-Fi, also known as this IEEE 802.11, whatever, they tell you what to do with layer 1 and layer 2. You got to have these radio waves. And the frame header has to look like this. When somebody plugs in an Ethernet card in the old days, you just go, oh, I guess you're a valid network. Here, come on the network. And you get a layer 2 frame. built on your MAC address. When somebody connected over a dial-up line, that's not what happened. You dialed into like what we use on our fax machines, the RS-232, and you'd go, wait a minute, give me your password, PAP or CHAP, and then you give them a layer 2 connection. You authenticated that. With Wi-Fi, it's a LAN protocol, but they might not be in the building. So they came up with a way to use like Radius or whatever it's supposed to be for dial-in in LANs, because it's a LAN protocol. That is known as running the originally for dial-in, up, we had SLIP, the first IP over the serial line. But then we went to PPP. PPP is great. And it's not just dial. PPP supports all serial connections. That's great. But what if I want to use this great authentication PPP supports with CHAP, the encrypted password, or the much cooler extensible authentication protocol? This allows you to extend it to Radius servers, to certificates. That's why Radius stands for Remote Authentication Dial-In User Service. They assumed you were probably going to dial in, even though they let other, just in case we should have some other serial besides dial. They let you to authenticate with this extensible protocol for your dial-in, and therefore all your remote authentic people dial-in could authenticate through this dial-in user service. But today, all you really care is EAP. And we wanted to borrow that for this. So we as if I had something to do with it, EAP over LANs, aka 802.1x. That's why you can use Radius for just any authentication user service. It should just be Radius, right? And that's how that works. That's enterprise mode of Wi-Fi. When you're using Radius in Wi-Fi, it's a very secure protocol, at WPA2 or 3. If you're not using Radius in WPA2, you're vulnerable to a password hack. Bluetooth, I think you connect your phone. I'm sure everybody has used their phone Bluetooth. Zigbee, they're using for a lot of IoT devices. I think, no, I was going to say, I think they use it in some automobile standards as well. I saw home automation, but I think some other. And I think you guys know what satellites are. I'm pretty familiar with satellite. Mobile networks use a form of EAP. Mobile networks like 4G use the EAP that does not provide mutual authentication, so you could easily do a man-in-the-middle attack against 4Gs. They are known as stingray attacks, so you only authenticate yourself. They updated the EAP ability on 5G, but we were talking about it was hard to roll out, EAP TLS. Let me see what the status is. Actually, let me just say it's Gemini. Though 5G supports EAP TLS and the testable thing to mitigate man-in-the-middle attacks. I hear, sorry, my text box in the way. I hear this wasn't actually implemented well or at all. Please advise. You're right to be curious. It's a strong security, but it hasn't been widespread as effective. Why hope? Yeah, let's go to Muse for, I want to see the mutual, but that's what it does. It does mutual authentication, right? Because it requires client and server certificates, versatility, blah, 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 blah. They can plug, it was hard to roll out. So actually, they're still doing 5G Stingrays. It's still vulnerable. Anyway. Network slicing, though, is kind of like setting up VPNs, but not at layer 2 at the radio waves, right? So this is pretty cool. They can do like a VPN that's 5G slicing, aggregated over multiple things, and assign different bandwidths, like kind of DSCP values at layer 3. But I can do the DSCP at the whatever physical or data link layer. So that's pretty cool. Improved encryption, but unfortunately. All right, we talked about these content delivery networks. It's really, really nice again, but that those caching controllers that are located at edge networks, first of all, they need to be protected so people can't, if I get to the cache, play the movie back, even though I didn't subscribe to it, right? So that's through encryption. But we also have to protect against some amplification attacks. Sometimes caching controllers are used to, do like cache poisoning. So we have to authenticate that as well. We talked about our software-defined networking. It showed up again. I told you there's a lot of redundant stuff, but I want to just be aligned in this. So when people even play back these videos, where's he at? Okay, 4.6. So, but if we remember to talk about this now. There is that cloud one I'm looking for. Virtual. Oh, the virtual private. This is it. This is it. And I recall getting some questions on there. So you can basically do VPN stuff cloud-wise, and it addresses not multi-tenancy, maybe Coca-Cola and Pepsi, probably more likely. It depends on the perspective, but whatever the sales department from the engineer developers, just keep those developers in a separate network or whatever. Do watch out for the term hybrid cloud, because in this context, this would allow me a connection between my virtual private clouds, my on-premise networks that are mirrored version things of each other, so I can now do cloud bursting and handle load balancing. It's common knowledge, in order to do cloud bursting, you need a hybrid cloud. And if somebody sees something on here that you feel I didn't cover, don't let me just skip over. I'm just trying to keep up with these things and not hit redundant information. We always want to be able to look and monitor, but it's hard to get real network observability and visibility. Again, if you watch your network with Wireshark, it's like watching a football game with a 30,000 power telescope. That's not really that useful. That helps in this particular thing. Getting visibility of your network traffic has always been a challenge. Everything from technically, it's hard to aggregate all that traffic into one interface for a console or something, collecting the information from the various networks, and getting stuff like that. But that's our goal. I can't manage what I can't see. So we try to get a peek into, there's, as myself, this is my own part of my job as I came up. I would only drew down on Wireshark after I would have a console that had my top conversations, my top protocols in use, So and the current network utilization across various things. And in those days, we might say average 30%. But then if I see it going higher, actually in a LAN segment, 2%. On an Ethernet segment, we average like 2% traffic. But if I saw that something unusual, then I go sort by the top conversations. Who's doing all this? And then it might be a server and a bunch of, well, who's the top talker in this conversation? Send that to Wireshark. So that's where those tools come in handy. But you got to be able to have dashboards that report on these things, give you your KRIs. And Key risk indicator, like I said, if it goes beyond 30%, there's something weird. A network architect is designing a new data center and needs to implement network segmentation. Which combination of approaches would provide the most comprehensive security while maintaining operational efficiency? Network segmentation, we generally think of, I got to separate this 192.168.1 from 192.168.2. I'm separating networks. Gee, it's the most comprehensive. I could take it down to that one kernel, microsegmentation, and it works great with the zero trust architecture, where they got to validate who they are, including the machines, with certificates. It uses the TPM chip. If you're using Microsoft, they look at that TPM chip and make sure you got the unique signature. That machine is approved. It's not just Bob. Yeah, very good. So if the machines behave, isolate that. And it's great in your incident response. And then remember your thing, it's detect, analyze, contain. This was a great containment measure. I swear, 3 or 4 questions. Though it wasn't always the right step because the containment wasn't right. Like, no, don't do your microsec containment. You haven't analyzed what happened yet. You don't know that it was confirmed. Somebody reported a breach. An organization is implementing a content delivery network, CDN, for their global web applications. Which performance metric is most crucial for optimizing user experience? Yeah, I don't care what the bandwidth is. Bandwidth would allow me to watch a 2-hour movie in like 5 minutes. That's not going to latency. Does it show up in 2 hours from the time? Yeah, it's a lot. In a software-defined network, which aspect of network architecture separates the management and data planes to enhance security control? So put everything at the controller, let them handle the control. If something goes out of control, I know where to look and gain control. Yeah, that's a great word for any security person, though. Again, even in GDPR, who's responsible? Would it be the controller? Are you supposed to control that? Yeah. A network administrator is designing traffic flows for a microservices architecture in a data center. Which type of traffic pattern should they primarily optimize? No, east to west, right? Because they're talking to each other at the same layer, right? Yeah, and it's funny because the thing about north south is they're talking to the controllers, in a way, as an application. That's kind of north. But if you're going to say that the microservices talk to themselves, that's especially if you're going through controller to controller, they might not be coming from the same server, right? In a virtual private cloud implementation, which logical segmentation method provides the most granular control over network traffic between applications? Oh, I skipped over it. Maybe you guys saw the bullet. It's not the answer there. No, it's not VLANs. I don't think it is. No, I think it's Bravo. Yeah, and I skipped over. I'm sorry. Let me go back and show you. Security controls include features like security groups, network access controllers. So I can say this group, I do like role-based access control, so to speak, but of access to the network. So yeah, I skipped over that, and I think that's what yeah, that's what I apologize, guys. That said, I want my money back. And a company is implementing 5G network slicing for different applications. Which security principle is most important to enforce? Hmm. Should this, but I don't hate A or D. It depends on the perspective. One thing, I'm just a paranoid hacker that radio is always vulnerable to at least the denial of service, but I'm probably overthinking it. Broadcast optimization would be an advantage of doing that, I would think, but I don't know that I need to enforce it. I don't, is there, bandwidth optimization. No, but it is Bravo. Bam, I read that wrong. I read that wrong. No, I want to make sure that I'm slicing up the bandwidth, that I'm giving the high bandwidth slices to the apps that need it, not the guy who's just, surfing the web. But I put our server, in one of the lower, quality of service groups. I think it's bandwidth optimization. Boy, I'm sorry that well, man, we're thinking secure. Let me read back. Larry, it's security, not avail. Sometimes to me, availability is security, but I think because they said security, I was supposed to think of confidentiality. Sometimes things do that.
It's network slicing. That's why it's micro, because that was my first choice. Yeah, it's not secure.
That would give me more security in that I could isolate things better, and that's probably security. I'm looking at, what did I tell you my job was?
They're talking about network slicing, not
Yeah,
defense and
I'm mostly my packet. I'm not really a security guy. Tom is a security guy. I'm really a packet analysis guy who's there to find out why it's so slow, and that's what drew me to there. It was my own bias that was wrong. I can see why this answer's better.
So why it is not the first one, defense in depth?
they're not talking about defense in depth. They're talking about if you have 5G. Can you go back? Oh, yeah. And can you go back to the question? The question gives the answer.
I can get his point too.
Yeah, network slicing. You're doing
Because yeah,
All defense in depth.
but defense in depth is networking architecture, but they're asking you about I'm using 5G network slicing for different applications. So what do you use? You're going to use microsegmentation for that because we're talking about application, not networking stuff.
Yeah, she's right. You're absolutely right, and it goes with the principle. I was saying that microsegmentation is Larry's Honda CRV. Defense in depth is Larry drives a car. This is precise. Defense in depth is not wrong, but the part is most that of microsegmentation is precisely the part of defense in depth that applies here. Great job. Thank you for finding that, and we appreciate it. In edge computing environment, which security approach is most effective for protecting distributed nodes? And I didn't see my physical, so I'm going to go with. Yeah, probably the zero trust. That's what I'm thinking too. Can't go wrong with that. Trust but verify. And again, the verification is PKI. Signed something, signed tokens, whatever. Which monitoring approach provides the most comprehensive visibility into modern network architectures? To my point. Maria, that's like watching a football game with a 30,000 power telescope. You won't know the score of the game.
SNMP, right? I don't know.
Simple network management protocol. You put me apparently. I think it's just a generic term they're looking for, and that's what you'd be observing, Ross. That's what I would be observing. So Ross's point, network flows are what when I watch IP import number, the segment packet, they're always available. I don't care if the data is encrypted. That's known as flow traffic, flow data, and that's what's always available. And this can help you do a lot of stuff, and that gives you observability. But I think they're saying the approach is
That's right. No, that's right. Monitoring is the key word. You're just observing.
yeah, yeah. I think it's going to be observed. Yeah, but the other ones are just too precise. You could be too precise. Like, what would you use to get from point A to point B? A car, a Honda CRV. Well, I could just use any car. A vehicle. No, it's got to be a Honda CRV. That would be wrong. Then it's precise is too bad. The company is implementing secure protocols for their wireless network infrastructure. Which combination provides the most secure configuration? Yeah, it's kind of easy there. WPA2 actually never supported TKIP. WPA did, and it was cracked very quickly. And that was a version of RC4, but whatever. MAC address filtering can be helpful, but I wouldn't use web. Yeah, well, that's the problem. WPA, because it is a TKIP, was cracked. Yeah, but you can use WPA3 with Radius, and that's WPA2 and WPA3 work with Radius, and either way they're very secure. The problem is WPA2 in personal is vulnerable because your passphrase is used to try to generate that passphrase, or the session key, I should say. Your passphrase is used to generate the session key. WPA3, it's different. Which of the following network architecture best supports the implementation of software-defined SD-WAN networks? Oh, I didn't really. That's a great question because I'm thinking the controller is the hub and everything else is a spoke. But I got multiple controllers. I should have a high availability. Wow, if I got the question, I would hope that it's full mesh, but if I'm only thinking one, it's a hub and spoke, right? The hub means that everything connects to the controller. It's fine, yeah. No, it makes more sense. Sure, because we're tying, right? I can't depend on a single point of failure, one controller. So good.
It's talking about the network, so it's everything.
And we can go 6 more minutes, and I think we can finish domain 4 because that was the longest part. These aren't as long. So and most of this we should kind of cover too already. So we're going to go over our basic, data center controls, service level understandings, media stuff. The network access controls, generally we think of again layer 2 stuff that would be like EAP type of stuff that control what MAC addresses are allowed to connect to the network, EAP over LANs. But again, in today's zero trust networks, where we're doing these API connections and just letting you do it at the other layer, we're not necessarily allowing machines on the network anymore. We're allowing applications to share APIs. Endpoint security. I hope I say this right because this is one of my wife's core tasks. So like CrowdStrike, may I brag? Because only because I know my wife's colleague is here. The CrowdStrike tool, the head of that place is George Kurtz, and I sparred him too, but not in a hacking thing. He wrote Hacking Exposed. And in 2000, this was the book. This was this is before the CEH. Everyone's like, what? He changed the world of network security. I got to give him credit there. And so I actually had a student bring this in. You got to read this. I read it. full disclosure how everything works. He told me I still have my little card, like Nmap switches and stuff. It's really cool, and how to do reconnaissance and all this stuff. So a year later, 2001, he has the ultimate hacking hands-on class, and they're handing it over to Global Knowledge in New York. I take the class, and I want to get it. So it's the very first his class ever. They have a 4-day class, and then the 5th day is a lab, the ultimate hands-on lab. And whoever gets through the hacking lab first wins an autographed copy. That's why I'm not a hacker. I'm a stupid network administrator who likes to goof around with Wireshark and other stuff, and I think outside the box. But really, my job is just maintaining networks, not breaking into them. So I even got into like debates with the guys. They're talking about, and if they didn't patch, Service Pack 2, you'd be able to do this and you'd be able to do that. Let's all take a lab and show them what else you could do if they didn't patch. I'm like, hold on. They're showing us all this labs if you didn't patch. But my use to the company is probably not learning all the things I could do to them if they didn't. Wouldn't that be more useful to and I'm thinking the trading firm, if I learned how to just do a better patch management program? And people like look at me like, oh, Microsoft loser. He doesn't know anything about hacking. Loser. You don't understand. Whatever. Get down to the last day, Ultimate Hacking Lab. I see people getting up and leaving. And actually, the labs were get through a Cisco router. I know Cisco pretty well. Get through a management tool that I use by Compact Insight Manager, do a reverse shell attack. I was like, I know how to do that. I did that. But then they had a Solaris box, and I had to do a very testable thing, port redirection. I had to get through a firewall that only allowed port 80, but I had to take SMB or a login request over 137 and get it to go over 80. I knew what to do, but I didn't know the command and all that. Now it's taking me like an hour trying to figure out this command. People are leaving, and finally I get to the last one. You got to display payroll.txt. And payroll.txt, you got to first authenticate as the guest account, steal the hash password database. And I told you Microsoft didn't hash their password. They still don't hash their local password. And they did something even worse. They only hashed 7 characters at a time. They didn't respect. It was really easy to crack an NT4 password, right? So I cracked the password. You got to go back in as administrator, display payroll.txt. There was a glitch that I knew from administration that if you logged in as a user and logged out, like I used to do it, I'd log in as my admin account and then log out, and then the user would use their machine again. It says you're still logged in. You have to reboot the machine. I was like, oh yeah, you know what it is? It's File Explorer. Don't open up File Explorer. Something about that. It keeps that open there, a persistent connection. When I did my attack, I did everything from the command. I get to payroll.txt. I go, I'm out. Almost everybody's gone. It's just the teachers and a couple students sitting in front of me. And I thought it had long been solved. And the guy goes, the guy in front of me, and it goes, you're not done. You got to display payroll.txt. Read them and weep. And I'm an idiot. I think they ran to that point. They couldn't log out and log back in again. All they had to do was reboot. Nobody thought of that one. And I go, I win the book, don't I? And the guy didn't even want to give it to me, this annoying admin and or security guy. And I go, I get the book, don't I? I'm the first. And he's like, here. And it's still on my wife's bookshelf. I dedicated it to her. That's when we were first dating. That's how I won her over. I hacked George Kurtz. And I have his autograph. By the way, that's part of the book. It's his autograph. Anyway, that's my one story. Now let's take our break. We'll get back here in 20 minutes and knock out the rest of this. Resume recording. All right, that's great. Thank you. And as always, thank you, Marie. You've been wonderful this week. Really do appreciate the participation. All right, so we kind of hit over this endpoint security, and the endpoint security again being a lot of times our endpoint being the server or the client, as opposed to looking through the network. Right. So if somebody opens up an SSL, a TLS, excuse me, whatever, an encrypted session, nothing in the middle can see that, prohibiting a man in the middle. When people write malware, it usually comes in the form of a phishing attack. So phishing attack comes in, you get an email because we don't have S/MIME certificates rolled out. PGP isn't rolled out in any big way. How do you know who sent the email? He said it was my bank. Is that true? You click on the link and it phones out to some server. There's nothing in there. It's not malware yet. Nobody detected malware. So you go out to the link and now your stateful inspection firewall wouldn't let anybody in unless you ask for it. And it goes, hey, I'm sending a TCP SYN out to this location. Look for a SYNAC from that IP to this IP, acknowledging that sequence number. Thank you. And he says, come on in. I don't know what you're doing in there. It's encrypted. Probably SSH, And now you download or just some file that's encrypted, some encrypted malware. And now you have to decrypt it. And it's encrypted with a local, session key. In order for that endpoint to really notice below the level of the operating system, because it might install kernel malware, whatever, it needs to, first of all, using the TPM chip, make sure any OS stuff is signed. But also, it will now decrypt that traffic. It'll decrypt that thing, that email or whatever, how it came back in. It's malware. But it's going to run it in a contained environment, a sandbox. And then it checks to see what it does. And so endpoint security using lower layer below the level of the operating system can inspect by running sometimes called a padded cell, run the malware, see what it does before it forwards it on. So endpoint security, very, very handy to really find out what the hell happened because so many devices in the middle will miss it.
But can't you also inspect when it's a request going out? So you can use like FireEye or WebSphere or something like that.
Yeah, well, that's where they're getting in trouble. There's a lot of things in order to be able to get just raw traffic and not an application's look at my network. I have to do something called promiscuous mode. I don't know if they still ask this, right? Promiscuous mode driver. Promiscuous mode. It's a layer 2 thing. You have to, in a hardware thing, you got to have admin rights to be able to turn that on. That means don't just listen for traffic like the Starbucks that calls your name. Process everybody you hear them call, right? So I'm going to listen to all traffic this way. Well, that has to be done on a lot of devices. Just like with TLS inspection for DLP systems, they have to do a lot of this stuff. So a tool figures, hey, we're doing this. Why don't we do that? But that wasn't their specialty. So again, CrowdStrike, which is doing great endpoint security, not necessarily rolled out their data loss prevention, which is doing a lot of the same thing in the same way, So unfortunately, it also reminds me of when we get into forensics analysis. I know we have a forensics guy here, so you're probably familiar with using tools like Encase to capture what's in memory. Well, endpoint security can capture what's in memory. That's how they maintain that state. They can look at it too. You know what they're not? Certified by legal forensics experts to be trusted in law as an e-discovery tool. So even now you got two things on your machine trying to do the same thing. So people try, maybe we can do that. Maybe we can do that. And they can inspect traffic going out. I don't know that they're great at it.
So it makes sense at the endpoint because that's where the request is coming from, closer to the device, right? So makes sense. But it won't use networking process, it's less.
Now where it doesn't come in. I can see that make sure it didn't went out, but then they didn't do their job in the first place. What they'll do, if they think a service got started by accident, they'll shut down that service. So there's a way where you're right. It'll limit what's going on what that thing's sending by right at the core saying, just block that service. We're not allowing you to do whatever SMB calls anymore. All right, so redundant power, they do have some basic questions. You can't just have a UPS that gracefully shuts down. I need a generator to continue to run and a lot of oil, and that takes a while to to fire up. So we generally have UPSs, not just to shut down gracefully, but to work alongside our generators to provide continuous power. Other stuff is we kind of hit here. Oh, ensuring that the cable secure, yada, yada, yada. I don't know. We need to beat up too much cable stuff. The physical NAC solutions, what they're really talking about is the physical MAC address. So the MAC addresses can be filtered or whatever, but MAC address you can lie about. You can't really. If I look at my MAC address, this is what my vendor description. Intel is my vendor. Well, let me get a different color here because there's something cool about this. And Intel, did you know that the IEEE, the Institute of Electricians and Electroniers, gave them that part? So you see 1E, 1D, EA, it's from Intel. So they get to change these. Do you think they ran out of multiple addresses? Yeah, a long time ago. So we've got cards out there with the same MAC address. And as long as they run on different networks, I don't care because it's rebuilt at every frame anyway. But if they show up on the same network, it is a problem. So they gave us tools to override this back in the 80s. You can't trust MAC addresses. These physical addresses are, I hope so. So network access controls do a few things. That's not the only thing, but that's one of the things we hope it can do. I could say, actually, my favorite network access control filter, only one MAC address. I don't care what it is, but I don't want you plugging in a switch or a hub and getting 5 machines in there. The continuous monitoring, integrated identity management, same. Endpoint security, again, these are things that can do intrusion detection from a particular, it's not a network intrusion. I also want to look at the host-based firewalls, host-based intrusion detection system, a holistic effect. Defense in depth, always just strong access control. A data center is implementing redundant power systems, which combination of components provides the most comprehensive power protection, not the cheapest one. UPS, backup generators, and redundant. Ooh, that sounds pretty comprehensive. And the rest of it, do they say only? Anytime it's just one only. Yeah, it's got to be. I just realized, Ross, your promiscuous mode reference. Used to always show up as a test because our IDSs need to do that. That was the question. What does your IDS sensor need to be configured? Promiscuous mode. Monitor mode, too, for Wi-Fi stick. Which transmission media characteristic is most important to verify when implementing secure fiber optic connections between buildings? Huh. I know what I would pick out of this. If it's between buildings, what's going on the other side? Yeah, B, attenuation levels is an important control, but fiber optic doesn't have much attenuation compared to copper. So people don't know, attenuation is loss of signal strength over time and distance. So in copper, I'm going to go 100 meters in any rated, twisted pair media before they, oh no, you can't go beyond that. You're going to have to get a repeater or something like that. But in fiber, I don't know how long it is anymore. It's like 35 miles or what, I don't know. It's something long, 28 kilometers, I think it would be. So I don't think attenuation is a problem. I'm worried about somebody hijacking, splicing the wire or whatever. So I think A is a better answer because they're between buildings. I don't know. Do I have administrative control over the ground between those buildings? Yeah. When implementing network access control, which authentication method provides the strongest security for endpoints? Very good, Mona. Yeah, MAC address fully could be spoofed. That's going to give me mutual authentication with TLS, but not at the API level the way MTLS will. Static IPs, that just sucks. VLANs, that doesn't even mean it's encrypted. Remember you guys were teasing? It's not A. No, it's got to be B, right? Remember B, it's not easy to roll out ETLS, but if you've got it rolled out, that means you're doing certificates for the clients and certificates for the server. This is what 5G was supposed to do for us. That's supposed to be the strongest way to authenticate. Yeah. Well, 802.1x is just EAP over LANs. And they're saying that in addition to having EAP, which you could use a passphrase like WPA2, right? Uses a passphrase. That's 802.1x. But they're not using passphrase. They're using certificates for both the client and the server. Yeah. Yeah. But where Ross is MTLS, again, this is going to give device access to the network. To the net, right? Like layer 2, layer 2. The zero trust that's probably going to grow, thank you, Ross, MTLS, is at the API level. I say API access. I say API access to APIs, right? Application to this application. So that's a lot less access, probably more desirable. It is zero trust, right? It gives me more micro segmentation for zero trust. But that doesn't mean 802.1x with ETLS isn't used somewhere. I don't know that anybody does. Again, we were supposed to do it for 5G, but it looks like it didn't come out, or at least limited. Yeah, mutual authentication. For endpoint security in a bring your own device environment, which combination of controls provides the most effective protection? I saw probably an out of scope there, but Mauro, I can answer that. Mauro's answer about PEEP. PEEP is a Cisco created, but later everyone liked it for a while because, for instance, ETLS is hard to get client search rolled out. It's hard to roll that out. You could do PEEP, and it's actually very popular in some scenarios because it's a lot easier to roll out. PEEP just requires the server to be authenticated. Very good, but probably out of scope. Stop wasting our time. Yeah, mobile device management, sure. I'm not going to waste our time. Watch everybody get a PEEP question. I don't think it's there, but it'd be funny. Oh, I didn't bold it, but yes. All right, 4-3. Let's see how fast we can get through this. Voice, video, collaborate. We kind of been through this, and we're going through Zoom, so that's pretty cool. Remote access issues we talked about. People used to dial in. We'd give them a clear text password with PAP, then encrypt it with chat. But then we EAP, let them do other things like radius servers and stuff. But again, that's giving you layer 2 access that is less favored. It depends. Now, are you connecting 2 sites? Hey. Maybe you could do the ETLS for that. It doesn't. Remember, it's for device authentication. It's not authenticating Larry. Is Larry's laptop ready? Is Larry's laptop authenticated? All right, whatever. I think we can. You guys better know this other stuff by just being in this class. The third part. All right, so it's great from understanding the traffic, knowing that like in SIP, we set up a communication, but RTP, a faster UDP traffic, those stuff. But the Zoom room traffic, we've all run into issues with Zoom, especially when I first got it or after COVID, and people were popping up into stuff, and you have to start locking in. But one of my favorite funny stories about Zoom and the CISSP objectives. Zoom, AES in ECB mode. There it goes. They made a whoops in their selection of encryption protocols. When we select a, I think I could probably do it here in a quick protocol. Larry, stop doing your live demos, please.
Larry, when they updated the Zoom application, it screwed everything up for me. I don't know what they did. That Zoom workspace or whatever they want to call it.
Yeah, they keep adding AI features that freak me out too. I keep losing like, hey, do you want to set up this visual layout? And I go, I don't know. Oh, I must have clicked it, and now I'm in there. All right. I guess what I'm trying to say is they picked a very insecure mode of AES, and it was always a text objective. It's the only one that begins with the letter E, and it's very easy to break. So there are various privacy concerns and whatever, and make sure that you're compliant. Probably we talked about using VPNs. Now, IPsec VPNs do it at layer 3, depending on your needs. TLS VPNs or SSL VPNs are a lot easier to configure. People set up VPNs with SSH. A lot of network admins. A lot of network admins that know that their network access controls won't let them get to that gaming server. So they set up a SOC proxy at home and they SSH to that. And then they get to the gaming server. Shadow IT type kind of problems. They're pretty common in some places. RDP, we know that it's very, very common. We need to lock it down. That was like one of the number one things to get hacked after COVID. That 3389. Yeah, but we need to ensure that they're authentic and whatever, MFA, blah, blah, blah. Privilege account management, we need to know why Bob is logging in as admin. I know you have admin rights because you're administrator. What happened Tuesday? What were you doing? So maintaining an audit trail and that they only go in and need to know, and we can track why people have to, what they're doing at that level.
Larry, there is a huge important, the NIST guidelines also give a lot of importance to privileged access management. So I just wanted to reiterate that it is really important to understand privileged access lifecycle, provisioning, deprovisioning, the risks associated with not doing appropriate deprovisioning. I think we covered that earlier, but yeah, understanding PAM is really
to where you schooled me in one of our previous classes. I know you've had quite a bit of experience at City with PAM.
Yeah, that's what I did for 8 years.
No, please chime in. I'm learning all the time. Always a student, sometimes a teacher.
No, that's all I wanted to talk about, like making sure that you understand what just-in-time access is, how auditing is really important when it comes to privileged user activities, what session management is, and things like that. So, what password managers are used for and what are good security best practices when it comes to privileged access controls. So just make sure.
They even got detailed about privilege access in the data center using a shared keyboard thing because the keyboard console could switch to multiple servers, and they had even gotten to that level of detail. So privilege account management is a holistic thing. But I always say, even in physical security, I can't prevent the physical security admin from opening up my room. But I can detect and ask them, why did you come into my room? And give yourself permission between 3 and 4. You always log for account privilege changes. Why did you give yourself admin rights to my folder for 2 hours? It's just unusual because I can't prevent you from doing that, but I could certainly detect it. All right, the data communications, how we, I think we kind of beat this up already in our SD-WAN and networking stuff. Microwave, whatever, there's nothing. We talked about the importance of transferring the risk of anything to somebody else. And this is when we get a third party to do and collaborate with. We can't prevent them from screwing up. We always make sure we understand what they're responsible for, a demarcation point, and where the line is in. And they generally spell that out in service level agreements that might not meet your needs. Again, they're typically developed in the favor of their service provider. They've had their lawyers check it, make sure they're not giving away the store. And then if you need to do something, you're going to negotiate exceptions to that in the contract. I think that's what Octaping. What's this? Oh, just in time with XML or SAML. Oh, that's a good question. I would think that certainly, that's the tradition to go uh, OpenID now. It's more restful, and you're not locked into XML only. All right, and then a lot of times you just get a managed service for whatever. I'm sure you people have service providers. All right, a global organization is implementing a new video conferencing solution for sensitive board meetings. Which of the following is the most important security control to implement? Probably end-to-end encryption. Remember, even IPsec only provides encryption to that IP address. TLS goes from this app to that app, from this web browser to that, from this Zoom client to that. So it's end-to-end encryption. When you think end-to-end, you're typically from one app to the other, just like WhatsApp or Signal, end-to-end encryption. Oh, well, that didn't help. I don't know what just happened there. I apologize for some out of order. Let's see what happens here. An organization needs to implement secure data communications between their main office and a remote office located 500 miles away. Wow. Their connection must be highly available and secure. Which of the following is the best solution? Okay. I love that they give us 500 miles. And I think the takeaway is whether you want to, you probably don't want to do a single anything, but you're probably sitting there going, wait a minute, is fiber good for 500 miles? But it doesn't matter. A is wrong because it's not single. If you want high availability, you need redundancy. So B is the only one that does it. Run that cable. A company is establishing connectivity with the new third party vendor who will provide remote hardware support. Which of the following is the most comprehensive approach to managing this relationship? Any of you chefs out there, subject matter, oh, you want to do A. But our managers know it's the service level agreement. Understand the rules first. Yeah. Before I engage. All right. If we at least kill the domain, that's not too bad. And it's not even 5 yet. I'm not going to start. Well, I can introduce the thing just to get every bit of time I can save, right? Where's my domain 5? Oops. Hey, I just noticed he didn't have test questions on that section. He's still working on the questions. Yes, I am. All right, I'm sorry. What's Larry's favorite part of that people overlook in the development life cycle? The very first step, who? If you get that wrong, nothing else matters. That's what we're all about here. Arpita has a lot more practical hands-on experience with this thing, so it is one of the domains I'm hoping we're going to phase over to you. But I have my own, at least biased take on things, my own experience, and I think it's extremely important. I got to know that it's really you, and once I know who you are, I need to limit what you can do. Now, on the exam, it's pretty important as we go to the cloud, and we use cloud to just validate my identity. I have an identity as a service provider. I go to Okta and they authenticate. But then once I'm authenticated, I get my SAML token and Open ID, whatever. And then I go to AWS and they don't say, who are you? Because I've already gone into the airport, gone through security. They already gone through the metal detector. They just say, let me see your boarding pass. Right. So that's what your SAML token's like, or what I did token's like a boarding pass. And their only decision is, now that I know it's Larry, which I've trusted that, is Larry allowed to access the payroll database? I'm sorry, Larry, you're not a member of payroll. Yeah, but you know that I'm Larry. That's not my point. So remember that in a cloud environment, the authentication is done by an identity provider. Authorization is done by the cloud service provider. That's up to them. Other things we'll probably talk about, access. Well, they have physical controls in here, so we'll talk about setting up physical things. But how to access information for a regular user, how to access privileged accounts type stuff, right? How to access the actual facility. One of my favorite things, I don't want to get too deep at the end of the day, but you badge into your data center. A lot of places, I don't know where they are today. I haven't been in a data center in a few years, but a lot of data centers were just motion detectors to get out. So people will traverse that access control by sliding a sheet of paper or something. There's I think another one. Oh, you badge in to get into the to the facility, and your friend's there, and you want to show him, and you give him your card, and he just badges in again. That card didn't ensure that only one person used it. So there are systems that could show up in your near future. One is passback protection. If I only badge when people come in, they can pass it back. I want to provide anti-passback. That's the term. And I do that by not just having them authenticate in. That badge is stateful. And now it knows, okay, it's in. If I give it to somebody else and they go, no, it says you're already in. You can't use that badge again unless you also egress authenticate. So what is the purpose of egress authentication? To mitigate that type of attack. But they still have two are man traps, and some people don't understand if you're not at a military site. And turnstiles actually, and you pointed this out, Arpita, it's still on every test as a turnstile. A turnstile at the New York subway system, I could jump over that thing. It would look funny. It would deter that type of attack. The turnstiles to get in a military base, you're not jumping over that. And two people are not going to fit through that thing. So turnstiles can help mitigate that piggybacking type of attack. Sometimes you'll hold the door for a guy, like when I said use my badge, that's a piggybacking attack. I said, I'll get on a ride. But if I just opened the door and someone followed me in, that's tailgating. It's a little bit different. Either way, it's how somebody could use your badge to gain access. I did tell you on my exam, the physical security questions were relatively simple, though. Like I used to have a lot of sophisticated stuff on, particularly cameras and other, like whatever intrusion detection systems that are really sophisticated. But now it was more like, hey, they got this set up, and you go, all right, that's a detective control. Do you got anything preventive or something like that? So it was relatively service simple. Probably get this. Everybody knows this. We already talked about classification. Everybody here knows what role-based access control. I didn't give the right to print to Bob. I gave it to that entire sales role. That's easy. Encryption. We do know that it kind of goes along with when you see role-based access control, do look for separation of duties and vice versa. There's sometimes when you think attribute could have worked and they're like, no, they're just saying separation, they just role would be fine. Don't overthink it. All right, we talked about encryption and key management, data loss prevention. We mentioned you got to keep records. Same with systems. We just went over the privileged account management. I am a passwordless guy. I don't want password and a PIN or password and biometric. I just want my token. I just want to put my FIDO key in there. I like passwordless. That works for me. Other environments said, we did a risk assessment, Larry. We don't mind the FIDO key, but we also want a biometric. You could do multi-factor with it, but you don't have to be multi-factor. It's still way more secure to do passwordless hardware based. That's all. We talked about a lot of this stuff already. We talked about the mobile device management, network access control, again, using 802.1x and MAC address stuff, biometric authentication, something you are or do. My signature is not what I are. So if you are examining my signature and I don't know if it's there, I want to give you more lighter stuff toward the end of the night. That might be worth it. If you just look at my static signature, well, it might be Larry, but it might be a really good artist. But if you examined it dynamically, yeah, that looks just like Larry's signature, but Larry normally takes a second. You took 5 minutes. Dynamic signatures are harder to spoof, that's all. And we talked about device encryption, encrypting our full disk and stuff like that, BitLocker type kind of things, keeping the keys in hardware. Is there anything new here that we talked about? I started to say man trap. So in some scenarios, in some places, some locations, and banks, but also I've been in a few. Actually, the first one I was ever in was at Peach Bottom Nuclear Power Plant back in the 80s. It took me all day to adjust a print head on a ribbon printer or something. I don't know, some printer repair. It took all day, and I had to go through this man trap. But it's a double set of doors where you go into one door, it's sealed, and then they made sure I wasn't, two people. It mitigates piggybacking, and I found that they weighed me too. But it's not like 180 pounds must be Larry. They weighed me both times. So they weighed me once. They said, well, we could tell if you walked in and it didn't look like you might have been concealing another person. If you weighed 400 pounds, but also since you weighed out that, but if you came in here weighing 170 and you left weighing 250, that would look suspicious too. So that was pretty cool. So man traps can help mitigate piggybacking and do other stuff. Single sign-on, that's an old term. You say that around my wife, she's going to criticize you and laugh and call Larry a loser. It's MFA. I'm sorry I'm sorry, I'm mixing something. MFA. Oh, they do. I thought it was. I'm sorry. I thought I saw 2FA. Don't say 2FA around my wife. No, single sign-on is when I only have to provide my credentials one place, right? And we do that whatever centralized controller in my domain. But if I do it outside, if I'm going to log into whatever all these different cloud providers and through a single sign-on, I have to have some CA sign, not necessarily a token. I mean, a certificate, just some SAML token or OpenID thing. I think we're getting to it. Shouldn't go too far. I think I did hit all these things. Anybody got any questions? Any closing concerns as we're wrapping up for the day? Let me see. Can I get through 5.1? Yeah, let's do that. Let's do these 5.1. We got enough time. Services, Zero Trust, everything, API gateway, everything else. I think I said it, but I just want to make sure because it's extremely important in today's world. OAuth allows different APIs to not only communicate because they're speaking the same language, like with REST, but I can say to you, now that I know who you are, you're only allowed to do this. But how do I know who you are? And that was the weakness. So OAuth 2.0 introduced OpenID Connect that allows us to get a better standardized way to authenticate APIs instead of letting developers make up their own stupid stuff. And I'm just going to say it one more time, Ross. And I think the best way to do that is with MTLS. All right, we already hit the zero trust. All right, let's try some. A multinational corporation is implementing a new data access control strategy. The security team needs to ensure that sensitive data is properly protected while allowing appropriate access for business operations. Which of the following is the most comprehensive approach? Yeah, I think we got to start with knowing what we're trying to protect and how to protect it. So I personally like Bravo. Isn't that what the whole point of classification and scheme on day one? And then we assigned if it's going to be top secret, then we're going to do it this way.
And this is a good example of questions being cross-domain. You could consider this to be like an asset security question or a domain 5 question. So it doesn't really matter. Just look at it holistically.
Look, they don't fit neatly into one domain. Yeah, I try to get that. I just take it and try to get everything right. And there you go. You get them all right, you're going to be fine. A company's IT department is setting up access controls for a new office building that houses both regular staff and sensitive R&D operations. Which combination of controls would provide the most effective security while maintaining operational efficiency? The pattern. Why is it always B? I think it's B again. I hope it's not falling into the pattern. And so it always be. An organization is deploying a new application infrastructure with multiple service components. Which access control implementation provides the best balance between security and operational effectiveness? And there, it's not always B. See that, Ross? We want granularity when needed, but not, I don't need it. Like if I say if the source IP address is not from my network, I don't have to get any granular than that. It's good enough. All right, that's probably a good time. Let me pause to be clear.